Hello students, welcome back to our channel Vagai Academy of Mathematics, and this playlist is CBSE Class 7 Applied Mathematics. We are continuously solving problems from our standard book ML Aggarwal and Neeraj Raj Jain. So following the previous session, this session we are about to solve exercise 4.2 from the concept of mensuration. And here if you see this exercise, we have got problems which are based on 3D mensuration. So we will have all 3D shapes, and also we will have questions which are based on all the 3D shapes. We are going to solve them. So if you have a view, we have questions based on the shapes. You see the following: cuboid, cube, and then we have a cylinder, hollow cylinder based questions, and also we have cone questions we have, and then sphere, hemisphere, hollow sphere. These kind of shapes are all there, and we also have questions which are based on these shapes. And what is going to be our plan is, as usual, we will be taking the problems one by one, and we are going to see directly the solution for the problems, and if any formulas which are related to that particular problem for that particular shape that we see in the question, we will just see those formulas there itself and we'll make use of it to solve the problem. So this will be the way we are going to take this session. Okay, yes. So yeah, fine, let's start the session. The first question: the dimensions of a cuboidal hall are 10 meter by 12 meter by 15 meter. So there's a cuboid shaped hall for which we have the dimensions given. Length is 10 meters, breadth 12 meters, and height is 15 meters. So we are noting down it, and this is going to be the cuboid shaped hall there. Now we need to find the length of the longest rod fitted into the hall. Now you can even imagine the room inside which you are sitting now. Now you take this room. Now what can be the maximum length, the rod of maximum length which you can fit inside this room? That you just think it. So the idea is going to be very simple. You need to take any one of those corners and you need to connect it with the other opposite end at the top. Okay, so one bottom corner, suppose if I am considering my room itself, so I have this one corner what I see here, and I need to connect this corner with straight opposite to that other opposite corner. So if we just connect it like this, that will be the maximum length we can fit inside this cuboid. And if you think properly, you see this red line what I have drawn here, this is going to be the longest the length which we can fit inside this cuboid. And this length is nothing but what? This is going to be the diagonal of this cuboid. Okay, now what about the diagonal is going to be square root of L square plus B square plus H square. Now this is a cuboid, three-dimensional shape, right? So for which this is going to be the formula. Now we can very well use this formula to solve this problem. So I have taken down the LBH, length, breadth and height. Now we can directly use the formula. So diagonal is going to be D is equal to square root of. Now what about L square? L square is going to be 10 square, which is 100, plus B square is 12 square, 144, and H square is 15 square, which is 225. So this will be equal to square root of. Now we need to carefully add these three numbers. Now you take these two numbers, this will be 144 plus 225. This will give you 369. 369 plus 100 will give you 469. So 469 square root. Okay, square root of 469 is going to be the answer. And if you see this 469 is not a perfect square, and we need to solve for this. Okay, so we can either use logarithm to find the answer for this expression, or otherwise we can even go for the square root calculation using the division method. Okay, so let me quickly use the division method itself. So in division I can do it like this: 469.0000. Okay, so up to 2 decimal places we need to find, so I'm just preparing like this. So now let me start with 469, and 469 is not a very big number, so we can quickly go think of the nearest square root, which is just before 469. So if you see here, 400 we have, right? So 400, and so 20 square will be 400 and 21 square will be 441. So we are almost this 469. So 21. So let's start from 21. So 21 times 21 will be 441. And now I need to minus. So 9 minus 1, 8. 6 minus 4 will be 2. Okay, now drop the next two zeros. So I have 2800 now. So what next we have to do now? So since after the decimal point we are dropping the zeros, here also in quotient also we need to keep a decimal point. Now I have 21. Now whatever I have in my quotients position, we need to double it. That is the square root procedure, right? So 21 into 2, double it, you will get what? You will get 42. So 42, and remember I need to fix one more digit here. 420 something will come here, and the same digit is what I am supposed to put here also, right? So what number can we put it? So we'll just try to have a guess. See here, this is 400s, but this is 2800s. So when I see it itself, I can come up to 7 times, right? But when I have exactly 400, this will be 7 times, but I have 420 something, so which means it will go up to 6 times. So 426 into 6, we'll do this way. So this will give you how much? 6 6 are 36. 6 6 are, it will be, sorry, so 6 6 are 36, I'm really sorry. So 6 6 are 36, 3 will be the carry. 6 2s are 12, 12 plus 3 will be 15, 1 carry, and 6 4s are 24 plus 1 25. Okay, so I have 2800 minus 2556, so I can make this as 100. So 100 minus 56 will become 44, and this 8 will be no more 8, this becomes 7. So 7 minus 5 will be 2. Now we'll do it for one more time. Drop the next two zeros here. So now I have 216 in my numerator position. So double this, I will get 432. Now 432, the next digit should come here. Okay, yes. Now what next digit I can insert here? So I have 4 here, I have 24 here. Just compare like this itself. The nearest thousands itself you compare. This is 4000s, but this is 24,000s, right? So 4,000 and 24,000, I can have 6 times or just less than that, 5 times. So go up to 5 times, 5 times. So I will be having what? So 25 5s are 25, 1 carry, and 5 3s are 15 plus 1 16, again 1 carry. 5 4s are 20 plus 1 21. So yes, so if I do it, definitely it will be less than this only. So it will be going like this because it will be an irrational number, so it will be going and going. So let's stop the process there itself. So I can approximate my answer as 21.65, and see the units. Our units is going to be meters, so the answer what we get for the diagonal length will also be in terms of meters only. So 21.65 meters is going to be the answer for your question number 1. Now moving to the second question. So here the question size itself is very big. I have just written the question in a short way possible. Okay, fine. Yes, for the full question, complete question, you can refer the book. So here, Nishant owns a house of dimensions 10 feet by 8 feet by 9 feet. So you have the dimensions of the house, the room which is given here. So these are going to be the length, breadth and height. It's very clear now. Now let's continue the question. His house has two entry doors with dimensions 7 feet by 3 feet each, and two windows with dimensions 3 feet by 2 feet each. So there are two doors and there are two windows. So total house structure, the dimensions they gave here. Along with that, they also gave the dimensions of the two doors and two windows. Okay, next what we have, if he wants to wallpaper his house with 2 feet wide, that is the wallpaper's width is going to be 2 feet. Okay, fine. Yes, so its length can differ. Okay, so the length we have to calculate as per how much area he needs to wallpaper, but the breadth is going to be, the width is going to be, they gave it to be 2 feet. Okay, yes, and the cost is going to be rupees 25 per feet. I mean, the cost of the wallpaper is going to be 25 rupees 25 per feet. Then find the total cost paid by Nishant. So to do the entire work, how much cost Nishant need to pay? This is going to be the question. Additionally, they also gave the labor charges is going to be rupees 10 per square feet. So now keeping all these informations, we need to work this problem carefully. Okay, yes. So let's first of all plan this problem. We'll work this problem in two parts. Now the first part is find the area first. Okay, how much area he needs to do the wallpaper work. So that we will first of all find it. Okay, so let's try to find the area first. Okay, so let me use this space to work the area. Okay, now listen very carefully. First of all, we have the dimensions given. We'll First find the complete area. Okay, for the 4 walls, the total area we will find it. Okay, yes. Now what about the area of the 4 walls? It is going to be 2h into L plus B, is it or not? So this is going to be the formula. Why? Because we have 2h, 2lh and 2bh. So because the 4 walls are there, okay, so each wall is going to be LH, LH, BH and BH. So two opposite sides across the length is going to be LH and LH, and the other two sides are going to be BH and BH. So these are going to be the dimensions. When I add it is what we are getting, this expression, nothing else. So now this is equal to, we already have the values of L, B and H in the question itself. So let's substitute it here. So 2 into, what about H here? H is going to be 9 into L plus B, which is going to be 10 plus 8. So I will be getting what? I will be getting 18, 2 9s are 18 into 10 plus 8 is going to be 18. So this is going to be 324 feet square. Okay, fine. Yes, because our dimensions are in feet, so the area will be getting in feet square only. Okay, fine. This is going to be the total area. But this area, out of this total area, we also need to calculate how much areas are going to be subtracted for the 2 doors and the 2 windows, is it or not? So let's calculate those areas also. So the doors area and the windows area, so we'll calculate those areas. So now what about the doors here? There are 2 doors, so 2 times of 7 feet by 3 feet each. So they are given the doors area to be 7 by 3. So that means 2 times of 7 by 3 is going to come. So 2 into 7 into 3 are going to be the total area of the 2 doors. So this will be how much? This will be 42 feet square. So let's note it. And next, what about the 2 windows here? The windows area, if you calculate, they are going to be also 2 windows. Okay, so 2 doors and 2 windows are also there. And 2 windows means 2 times of, what about the area of the windows here? 3 feet by 2 feet each. So that means each window is going to be 3 by 2. So 2 into 3 into 2. Now what about this one? So this will be giving you 2 into 3 into 2. This will be giving you 2 3s are 6, 6 2s are 12, right? So 12. So I will be getting, so 12 feet square for the windows. So totally, so overall totally 42 plus 12, I will have 54. So this 54 feet square will be removed from this total area 324. So the remaining area that needs to be wallpaper. Okay, so the wallpaper area alone is going to be what? Wallpaper area is going to be total area 324 minus the doors and windows area, which is 54. So if I do it, what I will be getting? I will be first of all getting 4 minus 4 is 0, 32 minus 5 is 27. So 270 feet square. So one part of the problem is done. Okay, yes. So for this area only, he is going to do the wallpapering work. Now the next part, we will calculate the cost. So how much cost will be taken, or how much cost will be required to solve, I mean like to wallpaper this particular area. And for wallpapering also, we are given the like what to say, the information given there in the question itself, right? So let's now concentrate on the wallpapering area. And again, in wallpaper area, we have got 2 different costs. One is for the wallpapers cost. Okay, one is for the papers cost and the other one is for the labor's cost. Okay, so 2 values, so 2 costs we need to calculate, and that total will be the final answer. Total is going to be the final answer. So we will work this also step by step carefully. First, you come to the wallpapers area. Now listen very carefully. We have the wallpaper is going to be 2 feet wide, is it or not? So the width is going to be 2 feet. Now you think and tell carefully. Our total area which needs to be wallpapering is 270 feet square, and if the width is going to be 2 feet wide, I mean width is going to be 2 feet, then how much length do we need to require? We need a length of 270 by 2 feet, is it or not? Because this is the area, this width, if I divide it, I will be getting the length itself. So that many feet length we need to cover up the wallpapering area, is it or not? So that much wallpaper we need. Now this is going to be the length we need to perform the wallpaper work. And what about the cost for this? Cost is going to be rupees 25 per feet. Now this much feet is what we require, and here the cost is going to be 25 per square feet. So now multiply this by 25. So 270 by 2 into 25. So let's try to work out this. So how much we will be getting here? We'll be getting this as, so first I will just cancel this. Oh, so first of all, how we can do this easily is, so let me try to do this in an easy way without complications. Okay, so first of all, what I will try to do is, so I will cut this. This will be 135, 135. Okay, yes, 135 times. Now what I will try to do here is, okay, I have some enough space. If I have, it will be better. Okay, yeah, this space is enough. Yeah, this is more than enough. So 135 by 25, this is what I want, right? Let me do a small thing. I will take 13500 because this is 135 into 100. That's what will give you 13500. Now half of this will be what? Half of this will be 6. Then I have one carry, so I will have 750. Okay, again calculate half of this one. So half of this one will be, this is 67, right? So 67 means 33, again 175. So 3375. So the answer for this question will be, this calculation will be 3375. I know what I'll just tell what I did here. Very simple. So from 135 into 100, I calculated half. So this will be nothing but 135 into 50. And again half of that will be 135 into 25, and that's what we got it here. Very simple. Okay, yes, so 3375. And what next I have to do is labor's cost. We need to find the labor cost also. So the labor charges is what? 10 rupees per square feet. So labor charge will be what? So for each square feet it is going to be 10 rupees. So totally it will be 270 into 10, which will be 2700. So this much rupees it will be costing for the labor's charge itself. So now I need to find the total cost. So what will be the total cost now? So total cost will be rupees. So let's carefully add these numbers. So first of all, 75 and 00 will give you 75 only, and then 33 plus 27 will give you 60. Is it or not? 60. So 6075 rupees will be the total cost for doing this entire work. Okay, yes, I hope the way how we solve this problem is clear to you. We are doing it in two parts. First part, I calculated the area for which we need to do the papering work, wallpaper work, and the next part is we calculated the cost. Individually we calculated, okay, for the material, wallpaper material, how much cost, then labor, how much cost, then total cost, how much. So we are getting the answer to be 6075 rupees, and that's going to be the answer for your question number 2. Next, we have question number 3 with us. The volume of a cuboidal block is 10,368 centimeter cube. If its dimensions are in the ratio 3:2:1, then find. We have two subdivisions. First one is we need to find the dimensions of the, like the cuboid. Okay, so that means we need to find the length, breadth, and height. Now we need to use the volume formula. We need to know what is the volume of a cuboid. Volume of a cuboid is length into breadth into height. And second subdivision, we have to find the cost of polishing its entire surface at a cost of rupees 0.50 per centimeter square. Now for this we need to know what is the total surface area, that is TSA of a cuboid. Okay, so TSA is two times of LB plus LH plus BH. So we need to know these two formulas in order to solve this problem. Now let's solve the problem one by one. Now come to the first subdivision. We need to find the length, breadth, and height. Let's take the length, breadth, and height to be, let us take them to be, just see the ratio which is already given there in the question, 3:2:1. So which means I can take the length as 3x, breadth as 2x, and height as 1x, which means x. That's it. Okay, so from this what we can understand is the volume will be nothing but 3x into 2x into x. So this will be equal to what? So this will be equal to this is what is going to be 10,368. Is it or not? So 10,368. Now what I will be getting when I solve this equation is, I will be getting 6x cube is equal to 10368, which means I will be getting x cube is equal to 10368 divided by 6. We need to divide it by 6. So we'll do the division. So let's do this division carefully. So x cube will be nothing but, I will be getting this as, so 6 in 10 will be 1 time. So 6 ones are 6, balance is 4. And now I have 6 7s are 42, balance will be 1, and I can go up to 6 6 2s are, right, 6 2s are 12 only I can go, so balance will be 4, and finally 6 8s are 48. So I get x cube is equal to 1728. So that means I will have x is equal to cube root of 1728, which is well known value 12, right? Because 12 cube is what is 1728. So x is equal to 12. We can easily get this. Now once I get the value of x, I can easily tell the length, breadth and height to be what? So length will be equal to 3x. So 3x means 3 into 12, which will be 36. What about the units here? See here, our volume is given in terms of centimeter cube. That means length, breadth, height, they will be in the form of centimeters only. Okay, 36 centimeter, and breadth will be 2x. So 2 12s are 24 centimeter, and height will be simply x, which will be 12 centimeter. That's it. Okay, so these are going to be the answers for your first subdivision of this question. And yeah, now come to the second subdivision. Here we need to find the cost of polishing, and cost of polishing the entire surface, which means we are going to just polish the entire surface, the total surface area. So for this one, first of all, we need to find the total surface area first. So what about the total surface area? It will be 2 into, now LB plus LH plus BH, this is going to be the total surface area, right? So let me do something. Instead of directly substituting these values here, let me substitute these values here. In terms of x, we will first of all find the value. Okay, so 2 times of LB, LB means 3x into 2x. So 3x into 2x will be 6x square. I hope you are able to understand this. Okay, I just multiply these values. So L is 3x and B is 2x, which means when I multiply LB, I will be getting 3 2s are 6x square. That's what I am putting it here. Similarly, what about LH now? LH will be 3x into x, which will be 3x square. And what about BH? BH will be 2x into x, which will be 2x square, right? So I will be getting this as what? So I will be getting this as 2 into, so 6 plus 3 plus 2 will give you how much? So this will be giving you 9 plus 2, 11. So I will be getting 2 times of 11x square. So 2 times of 11x square will be 22x square. Is it or not? So I will be getting 22x square. Now I can easily substitute the value of x here so that I can easily finish off this problem. That's the reason. So 22 into, what about x square now? X square is 12 square. So that means I will have 22 into 144, because you know 12 square is 144. So 22 into 144 will be basically what? This will be nothing but okay, let's do it like this. Let me rewrite this as 11 into 288. Okay, so because when I have 11 times of 9, I can easily multiply it. That's the reason. So this 22 I made it as 11, and this 144 I doubled it, 288. That's it. Okay, so 11 into 288 will be nothing but this will be 8. This is 8 plus 8, 16, and then I will have 1 carry. 8 plus 2 is 10. 10 plus 1 will be 11. Again 2 plus 1 will be 3. So this easy way to multiply this. So 3168. So 3168 centimeters square will be the total surface area. But of course, this is not our question. Our question is to find out the cost. Okay. So what about the cost of polishing this cuboid? This is going to be the question. Now what about the cost? Cost is going to be very simple. We know the cost is already given there in the question. It is given like 0.50 per centimeter square. So which means for this entire surface area 3168, what will be the total cost? It will be 0.50 into 3168. So if you carefully see this, this is nothing but half. So 1 by 2 of 3168. So what about 1 by 2 of 3168? It will be nothing but this will give you 15, 15, 15, because 31 means it will be 15 and balance 1. I will be having 16, 8, and then 8 by 2 will be 4. So I will be getting 1584 in terms of rupees. Okay, so rupees 1584 will be the answer for your second question. So I believe like both these subdivisions are clear to you. So the first question, the answer is length is 36 centimeter, breadth is 24 centimeter, height is 12 centimeter, and for the second subdivision, the answer is rupees 1584. Now these are going to be the answers for your question number 3. Next we have question number 4 with us. A rectangular plot is 24 meter long and 20 meter wide. Now see here, this is going to be the plot. Length is 24 meter, breadth is 20 meters. A cubical pit of edge 4 meter is dug at each corner of the plot. So in each of these 4 corners of this rectangular plot, what they are doing actually is they are going to dig a pit. Okay, yes. And what about the size of the I mean like the pit is going to be, the size is going to be is what is they are going to be cubical pit. Okay, yes. And also they gave that 4 meter. Okay, yes, the edge is going to be 4 meters, that is 4 meters by 4 meters by depth is also going to be 4 meters. Okay, fine, yes. So that is what they are doing here, and they are doing at each of the four corners. So that means four corners they are doing this cubical pit. And what next they are doing? Okay, four corners of the plot, and the soil removed is evenly spread over the remaining part of the plot. So they are removing the soil, right? So they are making the pit, four pits they are totally making, and the soil what they have collected from the dig, what they are doing is they are evenly spreading it into the remaining parts of this rectangular plot. Then if that is so, by what height does the remaining plot get raised? So definitely what happens, from the previous original height, the plot's height will be getting higher, it will be raised. How much height it will be raised? This is going to be the question. Okay, yes. Now this is also going to be a very easy question only. So let's plan it very carefully. First up, what we are going to do is we will just think about the four pits here. Okay, yes. So the four pits. So what about the four pits volume? The total volume we have to calculate. Now each pit, the volume is going to be a cube shape only. What about the volume of a cube? Volume of a cube is going to be A into A into A. Here what about the side? Side is what is A? Side is going to be 4 meters, that is 4 into 4 into 4, which means 4 cube. This is going to be the volume of each pit. But totally there are 4 pits they are making. So which means 4 times of 4 cube. This will be the total volume of sand collected there. So this will be nothing but what? 4 into 4 cube will be 4 into 64, which will be 256, right? So 256 meter cube will be the total volume of sand collected. I mean like yeah, the soil collected here. So this is going to be what? So 4 pits volume. This is done. Now we will think about the rectangular plots area, because rectangular plots area will be nothing but what? This length into breadth only, because area of the rectangle is going to be length into breadth. But what area we need here? We need not the rectangle's area, we need the remaining area. Remaining area is what we need, because out of these four plots, four pits which are they're going to dig it, right? So those four square areas will be removed from the rectangular plot. So we will think about the remaining area now. So remaining area will be what? Remaining area will be nothing but this total rectangle area, which will be 24 into 20 minus these four squares. Now what about the four squares? So 4 into, what about the area of the square? Area of each square is going to be a square. So a into a. So that means 4 into 4. Side of the square is 4 only, right? So 4 into 4, which is 4 square. And why I am making 4 into? Because 4 times of 4 square is going to be subtracted. That's why. Okay. Now this will give you what? So 24 into 40 will, sorry, 24 into 20 will be 480 minus. Now this is 4 into 4 square. This will be 4 cube, which is going to be 64. So now I will be having what? 480 minus 64. This will be 416 meter square. So this will be the leftover area of the plot. Now here is the task. Last one line we have to do. We need to find the raised height. Height we need to find. Now what will be the height? Very simple. The height will be nothing but this volume is what is going to be, I mean like evenly it is going to be spread over this area. So that means volume is going to be spread over the area. So to find the height, what I need to do is that volume I have to divide it by the remaining area. So remaining area, when I do this process, I can easily get the height. Okay, fine, because this is the content which we are going to spread over. So 250 meter cube of soil, this soil is going to be spread over this 416 meter square. So which means what will be the height? They will be spread evenly. To find that height is what we are doing this calculation. So this will give you the answer to be 256 by 416. And remember, this is in meter square, and this is, sorry, this is in meter cube, and this is in meter square, right? So when I divide it, our answer will be in terms of meter only. Okay, yes, fine. Now we will carefully just do this simplification process. So I can cut with what tables? I can cut with I think 16 tables itself, right? So 16 tables, this will be like how many times it will be? So this will go up to 16 times 16. 16s are 256. And what about 416? 416 in 16 tables will be like 20, because 25 into 16 will be exactly 400. I have 416 extra one time, so 26. So I hope you got the logic what I did now. So I just did 16 into 25 is 400, so 16 into 26 will be 416. That's it. Okay, so I got 16 and 26 here. One more time I can cut with two tables, so this will be two tables 8 times and this will be two tables 13 times. So I got 8 here, 13 here. That's all. Hereafter further we cannot simplify. So the height raised will be 8 by 13 meter is going to be the answer. Okay, fine. Yes. So I hope the way how we solve this problem is very clear to you. So let me just quickly explain it. Total area of the rectangle. From this, these four squares I'm removing, I'm getting this area, and in this area only they are going to spread this much of soil. Okay, yes, because they are going to dug out and take out the soil, so this much volume of soil is going to be spread evenly out. So to find the area, I'm dividing the volume by area. That's it. Fine. Okay, I mean to find the height, I'm dividing the volume by area, so I'm getting the answer to be 8 by 13 meter, and this is going to be the answer for your question number 4. Next we have question number 5 with us. A rectangular container whose base is a square of side 6 centimeter. So there is a rectangular box whose base is going to be a square. That's what they gave here, which means that container is going to be a cuboidal container. Okay, its shape is going to be a cuboid shape. That's it. Okay, so if you see this, the base is going to be a square. That's what they gave. So if you consider the base of that container, it is going to be 6 centimeter by 6 centimeter square shaped base you have with some particular height. That height is not mentioned. Yeah, let's see this. Stands on a horizontal table and holds water up to 1 centimeter from the top. So inside this container there is some water poured, and how much up to water is there? The water is going to be up to 1 centimeter from the top. Okay, which means what we can understand is, with this full height 1 centimeter lesser, only up to that height you have the water contained in that container. Okay, yes. Now continue the question. When a cube is placed in the water and it's completely submerged, the water rises to the top and 2 centimeter cube of water overflows. So now what is happening here? A cube is going to be immersed here. Okay, so they're going to place a cube here and they're going to immerse it. Okay, so now what happens is, the cube is going to be completely submerged. It is getting inside the water, and because of that, what will happen? Naturally, what happens is, like, the water level will rise up. Is it or not? So now what is happening? Read it very carefully. The water rises to the top. So whatever water you have there inside this container, the water is going to rise, and additionally also what happens? 2 centimeter cube of water overflows. Okay, so some water is going to be overflowing outside. So how much volume? 2 centimeter cube is going to overflow outside. Then in that case, calculate the volume of the cube. That's it. Okay, fine. So you have a kind of experiment in this question. So even though the question appears to be very long, the way of solving it is going to be very, very easy only. Very simple steps we need to perform. Okay, if you just know the simple physics laws, we can easily solve this problem. So actually the thing is, what here happens is, you're going to just put this cube inside. Now what happens when you put the cube inside? The volume of the cube will be equal to, okay, volume of the cube will be nothing but, it will be nothing but, now you have already water there. Now this, when cube enters into the water, what happens? The water will get displaced. Correct, it will be displaced. Now the volume of the water which got displaced will be same as the volume of this cube. That's a simple law we have. Now see here, additionally what happens? Now because of the reason you are dropping the cube inside this water, what happens is, the water level rises up, and also 2 centimeter cube of water is going to overflow, which means this volume of the cube, the total volume will be equal to the rise volume. Okay, the rise volume means up to the top. Okay, till the top, how much level of water is getting increased, how much quantity of content of, or the volume of water got increased, that rise volume, plus along with that whatever water which got overflown. Okay, overflown volume. Okay, fine. Yes, overflow volume. Let me write it as overflow volume. So when you do this simple calculation itself, you can easily get the answer. Okay, yes. Now we can very easily find the values and then get the answer. Now see here, rise volume means already it is up to this much level, just 1 centimeter below the top, right? Now it is going to rise up to the top. which means a height is going to be 1 centimeter. And what about the base of that? The base is actually a square only, is it or not? So the rise volume will be again taking the shape of a cuboid only. The cuboid whose dimensions are going to be 6 centimeter by 6 centimeter with a height of that rising level 1 centimeter, which means the rise volume will be nothing but the volume of that cuboid, which will be 6 into 6 into 1 plus and a plus the overflow volume is already there in the question itself. 2 centimeter cube of volume is getting overflow. That's what the water is getting to overflow that they gave there itself, right? So plus the 2. Now just do this calculation. You will be getting 6 are 36 into 1 is again 36. 36 plus 2 will be 38 centimeter cube, because we are doing the calculation in terms of centimeter cube only. Answer what we get will also be in terms of centimeter cube. So 38 centimeter cube is going to be the answer for your question number 5. Moving to question number 6 now. A hollow square shaped tube open at both ends is made of iron. So there is a hollow square shaped tube. Now you can see the figure, this is how it looks, right? That is, you have a tube whose cross section will be looking in the shape of a square, and its length is going to be some length. Okay, fine, yes, yeah. Now, how will be the structure is, this outer region, I mean the outer surface is going to be, it is going to be a square, and the inner is also going to be a square. Only then you get a hollow square shaped tube. Is it or not? Yes. Now fine. Now overall, if you look at the structure, it looks like from a cuboid, outer cuboid, from a bigger cuboid, you just take another inner cuboid, you just remove it out, then you have a hollow shaped which looks like this. Now you can clearly see this picture. The block line what I have drawn is going to be the outer structure, and the dotted is going to be the inner structure, the inner square. That's projection is what I have drawn here. Okay, yes. Now, yes, sir, we got to understand the structure now. Let's continue the question. The internal square is of 5 centimeter side. Now, if you see the internal square, the inner square side they gave it to be 5 centimeter, and the length of the tube is 8 centimeter. Length means they're talking about this one. Okay, I mean you can even consider this to be the height of this cuboid. The height of the cuboid is going to be 8 centimeter. There are 192 centimeter cube of iron in the tube. That means they're coming to tell you about the volume of this material, I mean this tube. So volume is given to be what? Volume is going to be 192 centimeter square. Let's just quickly note this. Then finally what we need to find is, find the thickness of this tube. Thickness means this one, okay. This is what we call it to be thickness, okay. You can take any side of this tube, I mean in the cross section wise, if you take any side, and this one, this thickness is what they mention it to be the, this is what they mention it to be the thickness, okay, fine, yes. So that measure is how much, that's what they are coming to ask here, okay. If I want to precisely show you, this length measure is what you call it to be the thickness, okay. That's what, how much they are just trying to asking you, okay. It will be uniform in all the 4 sides, okay, either here or here or here or here, okay, anywhere it will be same only. So how much is that dimension, that measure? That's what they are asking here as find the thickness. Now let's again try to solve this problem. So first of all, what we will try to do is, we have the length of the tube 8 centimeter given in the question itself, and also we are given the inner square's side is given 5 centimeter, that is also given. Now this outer side, there also we have a square whose side is not given, so we will take that side to be the square, that's square side to be, we'll take it to be some x centimeter, we'll take it to be x centimeter. Now this will give a clear idea for us to solve this problem. Now look at this, volume is given in the question itself. Now look at this particular shape, or this this 3D solid, and let's try to think of what can be the area, sorry, what can be the volume of this object, okay, yes. So the object's volume will be nothing but the outer cuboid's volume minus inner cuboid's volume. This if you do itself, you can easily get the volume of this whole object, okay, yes. So let me write it here, outer cuboid minus inner cuboid. So this will give you the volume. So this will be what, equal to 192, okay, yes. Now come to this outer volume, outer cuboid's volume. Outer cuboid's volume will be nothing but this is x into, here also x into 8, okay, because length into breadth into height, that is how we do, right? I'm just going to take these two are length and breadth and this is the height, okay, fine. Anyway you take it, anyways the answer is going to be same only. So x into 8 minus what about the inner one? The inner cuboid. Inner cuboid's dimensions are going to be, here the side is 5 into same 8 only. Now listen very carefully, inner cuboid's length is also same 8 only, okay, because the length is going to be present in a uniform way. So for which the volume is going to be 5 into 8. Now this is equal to 192. Now once you solve this itself, we can easily get the value of x, that is the outer square's side will be how much, that we will be able to get. First let us finish up this process. So first thing what I can do is I can just take 8 as a common factor outside. Here also I have 8. Here also I have 8. I am just taking the 8 as common outside. So inside I will have x square minus 5 5s are 25, because x into x is x square. Here 5 5s are 25 is equal to 192. Now what next I can do? I can just do x square minus 25 is equal to, here 192 will be divided by 8. So 192 by 8 will be how much? So 192 by 8 will be 24, is it or not? So this will be 24, okay, yes. Now that means x square will be equal to 24 plus this 25. I can bring this to the other side. This becomes 24 plus 25, which is 49. So which means I will get x is equal to plus or minus 7, because this is an equation and I solve it, quadratic kind of equation. When I solve it, I will be getting plus or minus 7. But since we are talking about the dimensions cannot take negative values. So x is equal to, I am restricting it here itself, x is equal to 7 centimeter, okay, yes. So that means we got to get the outer square side, which is 7 centimeter. But this is not the answer. Our question is what? We need to find the thickness. The thickness is what is our question, okay. Now how? The way we can find the thickness, let's think carefully, okay. The idea is going to be so simple but slightly critical to understand. So see that you are not getting confused at this point especially, okay. Now I got to know that this measure is 7, this measure is 7 centimeter, okay. That means here also it is going to be 7 only, this is 7, and this small in the inner square, this is going to be 5 only, okay, yes. Now I want this thickness only, that's what I want, okay, either here or here. Now just listen carefully, what happens when you do this 7 minus 5? If I do this 7 minus 5, I will be getting the remaining length alone, okay. What will be the remaining length here? So if I do this 7 minus 5, I will be getting 2 centimeter, is it or not? But the 2 is not the correct answer. Why? Because the 2 corresponds for, from this entire 7 you are removing only this 5. That means you will be left with this upper part of thickness and the lower part of thickness. That means you have 2 times of thickness remaining there when you do that 7 minus 5. Now for that reason you need to find the thickness. Just divide this 7 minus 5 by 2. That's it. The idea is going to be simple. So this will be like 2 by 2. Answer is 1. 1 centimeter is going to be the answer, okay. I hope the way how we solve this is this last step is clear to you. So 7 minus 5, if I do, I will be left with 2 times of thickness. Now once again I am dividing that by 2 to get the value of thickness. I am getting 1 centimeter. So yeah, come on, 1 centimeter is going to be the answer for your question number 6. Question number 7 with us. A rectangular pit 1.4 meter long, 90 centimeter broad and 70 centimeter deep was dug. So that means they are going to dig a pit here, and for the pit's dimension is what they gave here. They gave it to be rectangular pit, which means it is going to be what? The rectangular pit is going to be of a cuboid shape, okay. So first of all we'll try to take the pit's dimensions, okay. Since this pit is going to be a cuboid, so the pit's dimensions is going to be, so I'll note it separately here. So the length, breadth and height are going to be what? Length, breadth and height are going to be, this is 1.4 meter long they gave. So 1.4 meter. And next is breadth is 90 centimeter. And the height is going to be, height is what is the depth of the pit, which is going to be 70 centimeter. We'll take it to be the height, okay, yes. And what next they are doing? And 1000 bricks of base 21 centimeter by 10.5 centimeter were made from the earth dug out. So they are going to make the bricks, okay, and the bricks are also going to be what shapes? They are also going to be cuboid shapes only. So see here, they are going to make how many bricks there? they're going to make 1000 bricks. And for the 1000 bricks only, they gave the dimensions to be 21 centimeter by 10.5 centimeter. This is going to be what? The length and breadth of each brick. Now finally what we need to find here? Find the height of each brick. So we need to find the height. Now for brick also we'll note down the dimensions. Okay. Now remember, this is for the pit and this is for the brick. Okay. Each brick. Yeah. Okay. Now for the brick, what about the length, breadth and height? So length and breadth they gave. So 21 centimeter by 10.5 centimeter. Okay. Yes. Now what about the height? Height is what we need to find here. And how many bricks they are going to make here? They are going to make how many bricks? They are going to make a totally of 1000 bricks. That number is what? Count is what they gave here. Now we need to find the height. First of all, we'll try to relate this pit and bricks. Now the content or the volume which is made from, which is dug out from the pit is what they are making as the brick, which means what I can tell here clearly, that means it's very clear that the volume of the pit, okay, so the volume of the pit will be obviously equal to the number of bricks, okay, the number of bricks which is multiplied by volume of each brick. Okay, volume of one brick. Okay, we'll take it that way, volume of one brick. Now when I do this calculation itself, we can easily get the answer. Is it or not? Yes. Now let's try to carefully put the values here. Now going back to the dimensions, now all these values are giving in terms of centimeter except this length. Length is 1.4 meter. We know the relation between meter and centimeter. 1 meter is going to be 100 meters, which means I have 1.4 meter. This will be 1.4 into 100, 140 centimeter. That's all. And also it's very clear that both of them are going to be cuboid shapes only. We know the volume of the cuboid is length into breadth into height. Let's just directly substitute it here. So left hand side, volume of the pit is going to be 140 into 90 into 70. Now this will be equal to right side number of bricks. How many bricks are they making? 1000 bricks they are making. So 1000 multiplied by, what about the volume of each brick here? Length is 21 into breadth is 10.5 into height is not known, which is what we need to find. Height also we'll take it as h, and remember h we are going to take in terms of centimeters only, and all the dimensions are in centimeter. We will keep the height also in centimeters. Okay, yes. Now what I need to do here is simply I need to find out the value of h. We can solve this simple equation, we can get the value of h. So h will be nothing but, let us bring these terms to the other side, so that I will be getting 140 into 90 into 70, which should be divided by 1000, because these terms are going to be coming here. Okay, 140, 90, 70 divided by, now bringing these terms to the other side, so they will come as division. Okay, 1000 into 21 into 10.5. Okay, yes, 10.5. Okay, yes, 10.5. So this is how it becomes. Now we'll just carefully simplify this calculation to get the answer. So first step what I can do is, see here very clearly, I have 3 zeros in my numerator. I can cut them with these 3 zeros which I see in the denominator. And what next I can do here is, I can also cut this 14 and 21 in 7 tables. So 7 2s are, this is 14, and 7 3s are, this is 21. And once again I can cut this 3 and 9 for 3 times. So 3 times I am cutting this. Okay, done. Then what next I have 2 into 3 into, here I have 7 divided by, here 7 is there, divided by, here I have 10.5. Let me do a very small adjustment. This 10.5, let me rewrite it as 21 by 2. Okay, 21 by 2 is what I am supposed to put here. That by 2, denominator of denominator is going to the numerator's part. Okay, so I am doing this. Now make it simple. 3 7s are, is this 21. I can cut like this. So finally I have h is equal to 2 2s are 4 in terms of centimeter. Okay, yes. I am sure about the way how we are solving is clear to you. Okay, just have a clear look. Very simple substitution only we are just doing here. And this idea we need to understand. Okay, we are just comparing the volumes, because this is the total volume. This has to be equal to the volume of each brick into the number of bricks. That's what we are equating and then solving, and we are getting the answer. So height is equal to 4 centimeter is going to be the answer for your question number 7. So after taking a small gap, again I'm continuing this video. Next we have question number 8 with us. The inner dimensions of a closed wooden box are 2 meters, 1.2 meters by 0.75 meters. So now this is going to be the dimensions, I mean the inner dimensions of a closed wooden box. Okay, yes. And also you see here the thickness of the wooden box is going to be 2.5 centimeter. So clearly they are given this data. Now let us consider about how will the wooden box appear. Actually it is a closed wooden box, they mentioned it in the question itself. And if you consider the cross-sectional view of this wooden box from the top side, if you see, okay, suppose if you keep the wooden box here, the length, breadth and height will be there. So along the height, if you just view it from the top, and if you see the cross section, this is how the wooden box will be looking like. Okay, so for the clarity only I have drawn this diagram. Now look at this very carefully. Now what about the inner dimensions? The length is going to be 2 meters, breadth is going to be 1.2 meters. Now when we have the cross section from the top view, what happens is this is how it looks. Length is 2 meters and breadth is going to be 1.2 meters. Okay, yes. And if you have a close look, this shaded portion will stand for the thickness region of that wooden box. Okay, I hope you understand this, because this is going to be the inner dimensions only. This 2 meters and 1.2 meters are going to be the inner dimensions. So when you look at this cross section, you have a big rectangle inside which only you have the small rectangle, and for the small rectangles length and breadth is what you have this to be 2 meters and 1.2 meters. Now what can you tell about the length and breadth of the outer rectangle? How much they will be? It's very simple for us to understand. Why? Because see here the thickness is given to be 2.5 centimeters, that is given in the question. Now what even by thickness here? The thickness is nothing but this length is what they call it to be thickness. Okay, so uniform thickness, the width you see for that that border, you see that there, so you just see it there, right? So for that wooden box, this portion is what is going to be representing the thickness of that wooden box, and that length is what is given to be 2.5 centimeters. Now let us think about what can be the outer length and outer breadth. It's easy for us to find. Already the inner length is going to be 2 meters, correct? Then what will be the outer length? It will be nothing but this 2 meters along with 2 times of the thickness, because we have the thickness getting added on both the sides of this length, is it or not? So in that case, here 2 meters, here this side we will be adding a 2.5 centimeter, and that side also we will add a 2.5 centimeters. So along with 2 meters, you will have 2 times of 2.5, which is going to be what? 5 centimeters. So 5 centimeter will be added with this 2 meters. And now what will happen when you add 5 centimeter with 2 meter? Already we know 1 meter is going to be what? Let's note it clearly. So 1 meter is going to be 100 centimeter. We know this, which means every 1 centimeter is going to be every 1 centimeter. Just take the reverse one. 1 centimeter is going to be what? In terms of meter, if I write it, how much will be getting? We'll be getting 0.01 meters. Now we are going to add how much? 5 centimeter, because 2.5, 5 centimeters if we add means what happens is, with 2 I need to add 0.05 meters, which means this length will become 2.05 meters. I hope you understand this. Is the point clear to you? Just have a look again. 2 meters plus 5 centimeters. 5 centimeters will be nothing but 0.05 meters, because I need to mention the dimension in terms of meters, right? That's why. Okay, so 2 plus 0.05 is what is giving you 2.05 meters. Now this will be the outer length of that box. Okay, similarly, now what about the outer breadth of that box? Inner breadth is 1.2 meter. Then outer breadth will happen what? What happens to outer breadth? The same thing will happen here also. Okay, so 1.2 plus here 2.5, here 2.5 will get added. So that means here also we need to add 0.05 meters. So 1.2 plus 0.05 will give you 1.25 meters. This will be the outer breadth of that box. Now if you clearly think, the same kind of addition will what happen to the height also, is it or not? Because the height is also the third dimension, yes or no? So inner height, whatever inner height you have, along with that your outer height will become, I mean the outer height what I mentioned is for that wooden box, the outer surface what you see, for that one the outer height will become what? this inner height which is given to be 0.75 meters, from there you will have to add 0.05. So what happens, the outer and inner, the dimensions will be like, we'll note it very clearly. Okay, so here I'll write the inner, here the outer. Okay, yes. Now what about the length, breadth and height? For the inner values, it is going to be 2 meters and 1.2 meters breadth, and height is 0.75 meters. Now what happens to the outer measurements? Outer length, breadth and height are respectively going to be these values plus 0.05. That's it, very simple. So 2 plus 0.05 will be 2.05 meters, which is what we already got here. And same we did for breadth also, 1.2 plus 0.05, this will give you 1.25 meters, and same happens to height also. So 0.75 plus 0.05 will give you 0.80 meters. I hope you understand this. Okay, so simply you add a 0.05 meters with each of these, you will be respectively getting the outer dimensions. That's it. Okay, yes. But finally what we need to find here in this question, that we have to think very carefully. You see here, find the cost of the wood required to make the box if 1 meter cube of the wood costs 5,400 rupees. So this is going to be the question. I need to find out the cost that we have to spend to make the the wood. Okay, fine, yes, we need to take the wood. Okay, so that means how much wood we need to make such a box. This is going to be the question. So first of all, to find the cost, we need to first of all find how much wood we want. How much wood means the volume. We need to first of all find out the volume of the material. Okay, volume required to construct this wooden box material, so that we want. So volume will be equal to, very simple, what will be the volume? It's nothing but you have a big cuboid inside which only you have a small cuboid present in a hollow way. Is it or not? So that means that is what is giving you the closed wooden boxes structure. So from the outer cuboid's volume, I will subtract the inner cuboid volume. So when I do this, I will automatically get the volume. Okay, volume required to construct the wooden box. So let's try to find this one. So outer cuboid volume will be nothing but I have to multiply these values. Okay, because this is a cuboid, volume will be length into breadth into height. So which means I will be getting 2.05 into 1.25 into 0.8 minus. Here we have inner cuboid, length into breadth into height. Here I will be getting 2 into 1.2 into 0.75. This is what I will be getting. So now what about this value? This, when you multiply, what you will be getting? Now see here, 1.25 into 0.8. This will exactly give you 1, because this is like 125 into 8. So I will be getting 1000. When you properly keep the decimal places, you will come to get that. This will be like what? 1. Or otherwise I can even see this as a fraction. 1.25 is 5 by 4. 0.8 is 4 by 5. So 5 by 4 into 4 by 5. When you get it cancel, you will get 1. So when I multiply everything, I will simply get this 2.05 minus. Now come here. Here I will be getting what? 2 into 1.2 into 0.75. Now 1.2 into 0.75 will be like 1.2 into, this is 6 by 5, right? 6 by 5 into, what about this one? 3 by 4. So when you multiply these two things, you will be getting 0.9. Is it or not? If you have a doubt, you can even write it, work it out separately and check it. Okay. So let me take this small space to work it out. So 1.2 is 6 by 5. I'm writing as fractions. 0.75 is nothing but 3 by 4. Okay. So when you multiply these two things, you will be getting what? You will be getting here, you will be getting 3 2s are, this is 3 3s are. So I will be getting, I'll be getting like, 9 by 10. So 9 by 10 will be 0.9. Yeah, so we get 0.9 here. So 2 into 0.9 will be 1.80. So very simple. So 2.05 minus 1.80. When you subtract it, you will be getting it as how much? 0.25 meter cube. Remember, our answer what we are getting will be in terms of meter cube only, since all these dimensions are present in meters. Okay, so final volume will be 0.25 meter cube. But they are not asking us to find the volume. We need to find the cost of the wood. So finally, we'll find the cost. So cost will be 0.25 into, what about the cost per meter cube? Cost per meter cube will be what? If 1 meter cube of wood is costing 5,400 rupees, so 5,400. So 0.25 into 5,400 will give you how much? Now you can consider this 0.25 is just as 1 by 4. So 1/4 of 5400 will be what? So 5400, half will be 2700, again half will be 1350. 1350 rupees is going to be the answer. Okay, yes. I hope the way we solve the problem is clear to you. Have a clear view here. So what we have to basically understand and get convinced here is we need to have a clear comparison between the inner dimensions and the outer dimensions of this wooden box. So the simple relation is, with each of these inner dimensions, if I add 0.05 meters, I will be respectively getting the outer dimensions, and we get their volumes. We subtract it to get the overall volume of that box. Okay, fine. Yes, I mean the material. Now materials volume we will be getting. So that is what we got it to be 0.25 meter cube. And to find the cost, I am multiplying with the unit cost. So when I multiply it, I get the final answer. So 1350 rupees is going to be the answer for your question number 8. Next we have question number 9 with us. The ratio between the curved surface area and the total surface area of a right circular cylinder is going to be 1:2. So they gave the ratio of the CSA and TSA of a right circular cylinder. Now to solve this problem, obviously we need to know the formulas for the CSA and TSA of a cylinder. CSA is going to be 2 pi RH and TSA is going to be 2 pi R of R plus H. Okay, yes. Now if you see here, this R and H are going to be what? They are going to be the radius and height of the cylinder respectively. Okay, yes. Now if the total surface area of the cylinder is going to be 616 centimeter square, then find the volume. So this is going to be the question. Okay, all right, yes. So now what we do here is, we need to actually first of all get a relation between this radius and height, and then we have to find it, and then only finally we can solve this problem. Okay, yes. And of course we can take the value of pi as 22/7. Okay, yes. So by default we can take this way. Okay, yes. Okay, yeah. Now let's start from the first question of this first condition of this question. So we are given CSA and TSA. The ratio is what is 1:2, which means can we directly use this formula? Yes. Okay, yes. Now CSA is going to be 2 pi RH. So 2 pi RH, this quantity, divided by TSA. Okay, TSA is going to be 2 pi R into R plus H. Now this ratio is what they gave to be 1:2. So that means the CSA by TSA should be equal to 1/2. Is it or not? Very simple. Yes. Now let's try to simplify this. If I try to simplify, I can cut this 2 pi R from both numerator and denominator. So I will be having H by R plus H is equal to 1/2. Now when we try to cross multiply, what we will be getting is, we will be getting 2H is equal to R plus H. This is what we will be getting, and hence we will be getting what? We will be getting H is equal to R. So now we got to understand that H and R both are equal. Okay, yes, fine. So let's just mark this. H is equal to R means H and R are numerically they are equal. Okay, yes. Now what else is given in this question? We are also given, see here, the total surface area of the cylinder is going to be, it's going to be 616 centimeters square. Let's try to make use of that information also. Okay, again we have to use the formula of TSA only. TSA is going to be 2 pi R into R plus H, R plus H. So this is what is going to be what? 616. Yes, fine. Yes. Now let us just substitute two values here. One is 2 into, let's take pi as 22/7, and the other thing is into R into, what about this one, R plus H? In the place of H I will take it to be R, because already we got H is equal to R, right? So for that reason I will take R plus H. I will replace this H by R. Now when I replace this H by R, here what happens is this simply becomes R plus R, which will be 2R. This is what is 660. Correct? Yes, fine. Now what else I can do is, I can just do 2 into 22/7 into, here this will become 2R square is equal to 616. Yes, fine. Now let's try to carefully solve this equation. So now what I will be getting is, I can just cut the numbers on both these sides. Is it or not? So let's try to do it again carefully. So I will just cut this 2 and 616. So I can cancel this way itself, right? So 2 and 616, this will be like in two tables, this will be 308 times. 308 times, and once again I can cut with two tables itself. This 2 and this 308 will be 154 times. And now finally what I can do is I can cut this 22 and 154 for exactly 7 times, right? 7 times. So finally I will be having r square is equal to this 7, I can take it to the other side, 7 square, because r square by 7, because on the left hand side I cancelled all the numbers. So I will be having only r square by 7 is equal to right hand side 7. That means the meaning is r square is equal to, bring this 7 to the other side, it becomes 7 into 7. That's what I wrote it as 7 square. That means finally r is equal to 7 centimeter. We got this successfully. Okay, yes. Why centimeter? Because here the units they used is centimeter square to mention the total surface area. It is given to be centimeter square. So for the same reason I am taking r as 7 centimeter. Okay. Now remember, once r is 7 centimeter, what can you tell about h? H will also be 7 centimeter. Okay. So now it's very clear that r is also 7 centimeter, h is also 7 centimeter. That's it. Now we can easily get the answer to the problem. Now find the volume. Find the volume of this circle, right circular cylinder. So to solve this we need to know the volume formula also. So let me just take a note of volume formula. Volume of a cylinder, right circular cylinder, is going to be pi r square h. Okay, this is the formula, you can note it. And now I can use this formula here. Okay, let me do it directly. So pi r square h, first of all pi is 22 by 7 into r square, that means 7 into 7 into h will be again 7. So this will give you what? This will give you 7 and 7 I can cancel. So 22 into this will be 7 sevens are 49. So 22 into 49 will be the final answer. So let me write it, let me do this problem something like this. This will be like 22 into 50 minus 1. So 22 into 50 will be 1100 minus this will be a 22. So I will be getting 1078 centimeter cube, because we are finding the volume. Volume means it's the capacity, it's kind of capacity, okay, the solid space. So the respective unit should be centimeter cube only. So 1078 centimeter cube is going to be the answer. Okay, I hope the way we solve this problem also very clear to you. As I told, from the given condition we try to get a relation between the height and radius of the cylinder, and from there we find the radius and height measures, and from there we use the formula again to get the volume of the cylinder. Okay, so finally the answer is 1078 centimeter cube is going to be the answer for your question number 9. Next we have question number 10 with us. Rainwater which falls on a flat rectangular surface of length 6 meter and breadth 4 meter is transferred into a cylindrical vessel of internal radius 20 centimeter. So now there is a flat rectangular surface whose length and breadth are given, 6 meter by 4 meter they give. So in that surface there is a rainfall happening, and whatever water is collected there, it has been transferred to a cylindrical vessel whose internal radius is 20 centimeter. Okay, yes. Now let's continue this question. What will be the height of the water in the cylindrical vessel if the rainfall is going to be recorded as 1 centimeter? This is the question. Now we have to clearly understand that the rainfall 1 centimeter is happening where it is happening in this surface only. Okay, yes. So which means what clearly we can understand here is the water collected in this surface. Okay, water collected in the surface, should be equal to, it should be equal to the volume, because the same water is what is transferred to the cylinder. Volume of water collected in the cylindrical vessel, is it or not? So volume collected in the cylindrical vessel. So I'll take volume of water collected in the cylindrical vessel. So both these volume must be equal, is it or not? Because the same content of water is what is transferred from here to here. That's it, very simple. Now let's clearly look at this one, the left hand side. This is going to be the water collected in a surface. It is going to be a surface with some particular height, which means we can consider this left hand side object to be a cuboid, because we have a length and breadth for that surface. With some particular height only the rainfall is recorded. So which means what we can tell here, we can consider this as what? cuboid. Okay, so the volume of the cuboid, that is what stands for the volume of the water collected also here. So let's see this cuboid now. What about the length? Length is going to be 6 meters and breadth is going to be 4 meters. Let's do a small thing. We'll just convert the length and breadth to centimeters, okay, because the other quantities are given in terms of centimeters. So we will write this length and breadth also in terms of centimeters itself. Okay, so first of all I'll write down the formula which will be easy for you to understand. Length into breadth into height, the left hand side will be equal to this one, this side. What about the right hand side? Right hand side is going to be volume of the cylindrical, volume of water collected in the cylindrical vessel. Now this is going to be volume of the cylinder. Volume of the cylinder is going to be pi into r square into the height h. Okay, yes. Now what is the question here? We need to find what will be the height of the water in the cylindrical vessel. We need to find the height of the cylinder only. So let me do something. I will take the height of the cylinder to be what? I will take the height of the cylinder to be x. Okay, because I already used the notation h here. That's the reason I'm using x here. Okay, so this x is what we need to find now. Be clear with that. Okay, yes. Now let's carefully substitute the values. What about the length of the cuboid here? It's going to be 6 meters, so I'll take it to be 600 centimeters multiplied by, breadth is going to be 4 meters, so this is going to be 400 centimeters, and height means the height of the rainfall, that is going to be 1 centimeter only. Okay, this is 1 cm, please note it carefully. So 1 centimeter, so this will be 1, so this will be same as, now come to the right hand side, I have pi r square into x. X is the height of the cylinder which we need to find. Now what about pi? Pi we are requested to use as 3.14. So let me substitute the same value, 3.14 into, what about r? Radius of the cylinder, that is also given in the question. The internal radius is 20 centimeter. Okay, that is also there in terms of centimeter only. So no problem, we don't have to adjust it, the units. So 20 into 20 into the x. Now remember, when we solve for x also we will get in terms of centimeter only. Why? Because all these units I converted into centimeters. So when we solve for x also, we'll get the answer in terms of centimeter only. Okay, yes. Now first of all, what I can do here is I can cut the possible numbers, right? So how I can cut the numbers? So look carefully. What I can do here actually is, yes, let me do something like this. I will cut this 20 into 20 as 400. That's it. So that means I will be getting x is equal to, take this 3.14 to the other side. So this is already 600 into 1, which will be 600 only. So 600 by, I will be getting 3.14. That's it. Okay, yes. So 600 by 3.14 can be written as 600, and I will multiply my numerator by 100. So I will have 2 more zeros coming in my numerator. Now divided by, I have to multiply my denominator also by 100, right? Because numerator, when I multiply by 100, denominator should also get multiplied with 100 only. So 3.14 into 100 will be 314, 314. Okay, yes. So this is what we will be having, and let's try to solve this. Okay, so when you try to solve this, actually you will be getting some decimal values only, but anyways, we are given in the question as we need to find the answer to the nearest integer. Let's do that. Okay, yes. So this will be same as, so first of all we can cut with any common tables. Yeah, of course we can cut with 2 tables, right? So 2 tables means I will have 30000 divided by 157. So I'm cutting my numerator and denominator with 2 tables. So this becomes 30,000, and 314, when I cut in 2 tables, this becomes 157. Okay, yes. So that's it. Now hereafter we have to simplify only. So yes, so let's try to do some simplification. I think we can better directly divide it. Okay, so let's try to divide itself. So let's see what happens. So this is 30,000. I have to divide by 157. Let me see what is the nearest integer I'm getting. Okay, yes. So first of all, 157 in 1 will be 157 times. So balance I will have 43 and 1. So 1430 I will be having. Okay, 143, I mean like I'm dropping 1 0 here, 1430. Now 1430 in 57 will be how many times? So this will be like I can go up to 7 8 times. So 15 8s are 120. I can even try 9 times. Okay, So let me try 9 times. Yeah, I think 9 times also it goes. 9 times it goes. 157 into 9. So it will be like 9 sevens are 63. So carry 1. 9 fives are 45 plus 1 is 46. 4. 9 ones are 9 plus 4 will be 13. Simple. Okay, so I got 1363. Let me recheck it. 59s are 35. 130. 59s are 135. 135 along with the 63. Okay, let me check it. 9 sevens are 63. 6 is the carry, right? Really sorry. Yeah, 6 is the carry. So when 6 is a carry, what happens is like, yes, I'm really sorry. So this will become like 9 fives are 45. 45 plus 6 will be 51. 51. It will be 51. So 51 means I will be having a 51. 9 fives are 45 plus 1 is 63. Okay, 51. 1 will come and then 5 will become the carry. Correct? Yes. So once again I will have what? I will be having 9 ones are 9. 9 plus 1 is 9 plus 5 is 4. I will be getting 1413. This is what is correct. Sorry, I made a mistake. Yeah, now let's continue this. When I continue, I will be getting 17. So 17 will be the carry. I will drop one more 0, 170. So now what will happen is I will be having 170 and 157. This will be just one time, right? So one time means it will be like 157 times. So yeah, so we'll be getting and we'll be going. So this will be 2 less only. So 191. So the nearest integer, because after this we'll have to do decimals only. So the nearest integer what we got is 191. So 191 is going to be the height of this cylindrical part. So up to 191 centimeter we will be having this cylinder's height filled. Okay, yes. So yes, that's going to be the answer. So 191 centimeter is going to be the answer for your question number 10. Moving next to question number 11. The curved surface of a cylindrical reservoir which is 12 meter deep is plastered from inside with concrete mixture at a rate of rupees 15 per meter square. So there is a big reservoir in the form of in the shape of a cylinder, and they gave it is 12 meter deep. That means the height of the cylinder spot is 12 meters. That is what we have to understand. Now what they are doing is, this cylinder they are plastering in its curved surface region. And what about the plastering details they have given? So they are plastering the curved surface with concrete mixture and whose rate is rupees 15 per meter square. Okay, yes. If the total payment made is rupees 5,652, then find the capacity of this reservoir in liters. So this is what we need to find. So in order to solve this problem, what are all the formulas we require is, as usual, we need to know the curved surface area. Okay, this is a cylinder shape, and for the cylinder we need to know about the curved surface area, which we already know, 2 pi RH, and also we should know the volume of the cylinder, that is going to be pi r square h. Remember, pi we need to use it as 3.14. It is instructed in the question itself. And one more important thing also we should know in order to solve this problem. Look at this last line of this question. Find the capacity of the reservoir in liters. We need to find the volume. Capacity is what is volume, right? So we need to find the volume in terms of liters. Now you see this problem, all these units which are mentioned here is in the form of meters only. So that means when we try to calculate the volume, we will be getting as meter cube. The volume's unit will be in terms of meter cube. Now I have to express my answer in liters, which means I should know this one small connection between meter cube and liters. It's very simple. 1 meter cube of volume can occupy 1000 liters. Okay, yes. So this also we should be knowing. When we are knowing all these things, we can very comfortably solve this problem. That's it. Okay, yes. Now coming back to this question, start from the first piece of information. What is that they are given? They are going to take the curved surface area of the cylinder and they are going to plaster it. And for plastering only, the cost is rupees 15 per meter square. Which means what about the total cost? The total cost they gave it to be 5652. Which means, shall we understand something here? We can understand very clearly something. They are doing the curved surface area only. So that means the curved surface area should be equal to the total cost, which is 5652, divided by this rate per meter square, 15 rupees. So when I divide it, I will obviously get what? I will be getting the, what to say, we will be getting how much meter square we have in the CSA of this cylinder. That's the idea, simple idea, okay? So yes, so let's try to simplify this fraction. So it will not be divisible perfectly. Though it is not divisible, we'll try to simplify this fraction. So when we look at this fractions very clearly, both my numerator and denominator will be divisible by 3 tables, correct? So let's try to cancel with 3 tables. So 3 tables means I can go up to how many times? I have 5, 6, 5, 2 in my numerator. So 3 tables means I can go up to 18 tables, right? So 3 18s are 54. I will have 54. Balance will be 2. And once again, I can have 25. 25 means 3 8s are 24. 3 8s are 24. Balance will be 1. And 3 4s are 12. We will have 3 4s are 12. Yes, exactly. Divided by, now denominator also, if I cut with 3 tables, I will be getting 5 here. So 1884 divided by 5. So this is going to be this much meter square. This is going to be the curved surface area of our cylinder. Okay, yes. Now let's try to use a formula. Formula of the CSA is going to be 2 pi RH. Let me directly use it. 2 into pi is going to be, as instructed, 3.14 into, what about the radius? Radius, we don't know how much it is. So anyways, r into, what about the height of this cylinder? See here, that is also mentioned, 12 meter deep, which means the height we have to consider it to be 12 meters only. So 12 is going to be what? This is going to be 1884 divided by 5. Okay, yes. So this curved surface area formula, I am equating it to the curved surface area of the cylinder. Okay, yes. So now what next I can do is I can try to simplify now. So when I try to simplify, I can cut with what other numbers is like, yes, so I will cut with, fine, okay, I'll directly try to cut with 12 tables itself. Okay, yes, let's see what happens when you try to cut with 12 tables. So I think it will be divisible. So yeah, it will be divisible only, right? So 84, yes. So 12 tables, so it will be like 12 ones are 12. Balance will be 6. 12 5s are 60 and balance will be 8. 12 7s are 84. Success. 157 times in 12 tables. That's it, done. That's all. Hereafter we can't go for any kind of simplification, I think. Yes, that's all right, no problem. Okay, now come here. I have my left hand side as 2 into, this is like 314 by 100 into r. Now what about my right hand side? I have 157 by 5. This is what I have. Now I can easily solve this by looking at the numbers itself. We can guess it, right? So now what I can do is I can now cut this 157 and 314 for exactly 2 times. Success. Okay, what next I can do now is I can now cut with what other tables? So 2 and 2, this is 25 times. So r is equal to, bring this 25 to the other side, 25 by 5 alone we have. So 25 by 5 will be 5. So successfully we got the radius. Radius is 5 meters. That's all. Okay, yes. So now we got to get the radius of this cylinder, which is going to be 5 meters. And also height is already going to be 12 meters. That is also there. Now all we need to find is the capacity of this tank. Capacity means we need to find the volume. Okay, so I think this space is enough for us to get the volume. Volume is equal to, it's equal to pi r square h. Let's use this formula, pi r square h. So pi r square h means pi, which means 3.14 into r square. It's going to be 5 into 5 into, and what about this one? Height. This is going to be 12. That's it. Okay, yes. Now we will clearly solve this one. Okay, since we are involving decimals and all, let's try to solve this also very clearly. So what I will try to do now is I will better write this as 314 by 100 into, this one will become 25 into 12. Is it or not? Yes. Okay, so 25 and 100 will be 4 times, and 4 and 12 will be 3 times. So 314 into 3 will be 942 meter cube. Why? Because the answer what we will be getting with these measures will be in terms of meter cube only. So volume will be in meter cube, but we want our answer in terms of liters. So that means this 942 meter cube can be given as 942 into 1 meter cube is 1000 liters, is it or not? So 942 multiplied with 1000, you will get 942 followed by 000 liters. So 9,42,000 liters. So I hope the way we solve this problem is going to be very clear to you. This is the answer. Okay, yes. So what we actually do here is, first of all, with this given cost, we find out the CSA. With CSA, we solve for the radius. So we have the radius and height, both the things are available with us now. With that, we just find the volume of this cylinder, and finally we express the volume in liters. That's all. Okay, so this is the overall process we are doing here in this question. And yes, 9,42,000 liters is going to be the answer for your question number 11. Next with us is question number 12. Very easy question. If the height and the radius of a cone is tripled, then find the ratio of the volume of the new cone and the original cone. So this question is based on cone. So basically we need to understand the structure of a cone, and also we need to know the formula. Okay, we need to know the formula to calculate the volume of a cone. Volume of a cone is 1 by 3 pi r square h. This is the formula. Okay, where r is the radius, h is the height. Okay, fine. Now I've just made a kind of small table here comparing the new and original measures. Okay, because there's a cone and you need to make some changes in the dimensions of this cone, the original cone, and so you get a new cone. Yes. Now, so to make it, I made a comparison like this. Now let's start from the original cone itself. We'll make the values very easy. I'll take the original cone's radius to be 1 and height also as 1. So that means what happens to the volume of this cone? Volume will be nothing but 1 by 3 into pi r square into h. That's the formula, right? So pi r square h means pi 1 square into 1. This will be the volume of my original cone. Now come here, new cone. Now for this new cone, what happens? The height and radius of this cone is going to be tripled. Tripled means, you know what, 3 times. Okay, this means 3 times into 3. That's the meaning of tripled. So radius will become 1 3s are 3 and height will become 1 3s are 3. So now the radius and height of this new cone are going to be 3 and 3. Now what about the volume of this new cone? It will be nothing but 1 by 3 pi of r square into h. Now for this cone the radius is 3, so 3 square into height is also 3. That's it, very simple. Now I need to take the ratio of these two quantities only. Yes, okay, fine. So this will be nothing but 1 by 3 into pi into 3 square into 3 is 27 is to 1 by 3 into pi into, what about this 1 square into 1, which will be simply 1. That's it. Now I can easily cut this 1 by 3 pi on both these sides because we take the ratio only. That's why, right? So now this will simply become 27:1, and that's going to be the answer. Okay, I hope you are clear with the way how we are solving this problem. No need to complicate the problem. We can easily assume the values, and from there itself we can easily get the answer. And also I'm not confusing with the units. That is not even necessary. Why? Because whatever units you take, the same units are only going to come here also, and it is going to get cancelled in terms of volumes also. That's the reason I'm simply playing with the numbers itself and getting the answers. So 27:1 is going to be the answer for your question number 12. Next we have question number 13 with us. A cone is surmounted on a hemisphere as shown in the adjoining figure here. So now you can see the structure. There is a cone. It is going to be mounted on a hemisphere. So you have a hemisphere shape at the bottom, and over which is what you need. You have a cone. Okay. So this is the structure. Now, yeah, you can see it. The radius of the solid formed is 6 centimeter. So that means if you see the radius is going to be a common measure. The radius of this cone and the radius of the hemisphere, both are going to be common, and that is what they gave it to be 6 centimeter. Okay, so let me note it here. Radius is 6 centimeter. Fine. All right. Yes. And what next is given? and the height is given to be 21 centimeter. Okay, so height is going to be 21 centimeter, means the total height is going to be 21 centimeter. So total height is 21 cm. Now when you look at this data, this 21 stands for this cone portion's height along with this hemisphere's height. Okay, now if you look at this one, the hemisphere's height will be nothing but its own radius only, because for a hemisphere, radius, height, everything is same. So in that case, this radius, if it is 6, means I can understand that this portion will also be the same 6 centimeter for this hemisphere, right? Yes. Now when we concentrate on this height portion, I mean this cone portion's height alone, if you want to see, it will be nothing but this total 21 minus this 6. So I will be getting it to be 21 minus 6, 15 centimeter. So the height of the cone portion alone will be 15 centimeter. Okay, yes, fine. Now next is what are all the things we have to find here, that we will see. We need to find the curved surface area of the solid and also the volume of the solid. So we have to do two calculations here. One is to find the curved surface area and the other one is to find the volume. Let's do it one by one. But before that, we will make use of the formula. Okay, so see here, for cone, the curved surface area CSA is pi RL, where L is nothing but the slant height of this cone. Okay, yes. And what about the volume? Volume will be 1 by 3 pi r square h. And for hemisphere, if you see, you have the only dimension which is going to be radius. CSA is going to be, curved surface area is going to be 2 pi r square, and volume is going to be 2 by 3 pi r cube. So these are the formulas we are going to use here to solve the problems. Okay, all right, yes. Now once again coming back, here we have the radius of this cone, radius of the hemisphere, and height of the cone. Everything is available except this L. L is going to be the slant height of this cone, is it or not? So that L alone we have to find it. Now how to find the value of L? It's going to be very easy. We are going to use the Pythagoras theorem to find out. Okay, why? Because you see, height of this cone and radius of this cone along with the slant height of the cone, those three sides will make the when you just complete it, it will make a complete right angle triangle, and hence I can use the Pythagoras theorem to find out the missing side, which means L. I can find it here itself. Okay, yes. So L will be nothing but what? It will be nothing but square root of this radius 6 square plus 15 square. So when you do this, you will be getting this as square root of 36 plus 225. So 36 plus 225 will give you 261. So 261, is it or not? So if you want, you can even add it and see. So this will be nothing but, so I'll use this space. So 36, 225, yeah, this will be giving 1 carry 6, so 261. So square root of 261 is what is going to be the value of this L, and square root of 261 we have to find it, right? So we'll try to find it somewhere here. Okay, I think we have some enough space here. Let me use this space to do that. So square root of 261 means I will start from here. So I can go with, first of all, 16s are 256. Okay, yes, why? Because the nearest square root is 16, we know that very clearly. So 256 up to which we came. Now hereafter we have to keep decimal point only. I'll just find one decimal point. Okay, so I'll drop 00. So what happens here also is I will have to drop the same 00 here. So when I try to do it, I will be getting 5, so 500. So when I double this, I will be getting 32. So now 32 and 500, this will be only one time it will be going. So again 321, I have to drop it. So I will be getting 179. So 179, if you try to drop the next double zeros and do it, you will be getting what is, you will have to take it as 322. Why? Because 161, when I drop it, I have to double it. 322 I will be getting. Now 322 to the next place, I have to drop one place. So this I will be getting it around some 5 or 6 times, right? So I will be getting it around some 5. Yeah, it will come around some 5 times. So let's take this to be 16.15. Okay, so to be nearest 16.15 centimeter. So we'll just take for 2 decimal places. Let's see what happens. So 16.15, this is going to be the value of L. That's it. We got everything, whatever we want now to solve the problem. Let's use formulas to get the answer. We'll do this one by one. First one, to find the curved surface area. So to find the CSA, what we have to do for this structure, if I want to find the curved surface area, I should basically add the curved surface area of the cone plus curved surface area of the hemisphere. That's it. Okay. So we know both the things. Curved surface area of the cone will be nothing but pi RL plus, for this one, for the hemisphere, the curved surface area is going to be 2 pi r square. Is it or not? Yes, since pi is common and r is common, let me take them out. So I will have L here plus 2r here. Okay, yes. Now what next I can do is I will take this pi as we can either take it to be 3.14 or 22/7. So let me take any one of them. Okay, so I will take it to be better 3.14. Let me see what happens. So into r is going to be what? R is going to be yeah, that's a common radius, so which will be 6 into, now inside I have L plus 2r. L plus 2r means L is already 16.15 plus 2r will be 2 6 are 12. Okay, yes. So 3.14 into 6 into, now what about this expression? This will be 16 plus 12, 28.15. Okay, yes. So now when I complete this will give me answer. Okay, yes. So since this calculation is going large, let me use my calculator, okay, which I have in my mobile. So 3.14 into 6 into 28.15. So this comes around 530 point something. Okay, yes. So this is what I'm getting here. So since we are making too much of approximation, we can expect the answer also in that approximated way only. We will not be able to get the accurate answer. So 530 or 531. So something like that around this way, around is what we can expect our answer. So this much centimeter squares is going to be the answer for your first subdivision here. And next is volume. When you come to volume, here we have volume of this solid. Volume of the solid is going to be actually equal to same thing, volume of your cone plus volume of your hemisphere. Okay, so we need to add both the things to get the answer. So yeah, if you see the volumes formula, it is going to be like what about the volume of the cone? It is going to be 1/3 pi r square h plus volume of the hemisphere is going to be 2/3 pi r cube. Okay, yes, fine. So here also I can remove what common things I can remove. Pi and then r square by 3 also I can remove it outside. If I do it, I will be having h alone left here and a 2r alone left here. Okay, yes, nice, going good. So now pi, I will as usual take it to be 3.14 into r square is going to be 6 into 6, right? So 6 into 6, which means 36/3 into, inside I have h plus 2r, where h is going to be the, remember that, okay, h is going to be the height portion of this cone, okay, which means 15 plus 2r means 2 into 6. So now this I will be getting 3.14 into, I can cut this for 12 times, multiplied by, this is 15 plus 12, which will be 27. So now when I do it, I will be getting my answer as, so let me complete it and see what happens. So this will be 12 into 27 into 0.14. So I'm getting my answer around 1017.36. So yeah, the approximate answer. And here we are finding the volume. This will be centimeter cubes. Okay, yes. So the approximations is actually because of the reason we are approximating the values of pi, and also we are approximating the value of this root of 100 and 261. Okay, that's because that's the reason for these kind of approximations. So the more accurate values we take, the answer also we will be taking will be accurate. Okay, and hence you can note it, 531 centimeter square is going to be the answer for your first subdivision, and 1017.36 centimeter cube is going to be your answer for the second subdivision. Yeah, these are the answers for your question number 13. Moving next to question number 14. A cubical gold block of dimensions 9 centimeter by 11 centimeter by 12 centimeter is melted. So you have a cubical block, which means like it is a cuboid, and they have given the dimensions of this cuboid. So this is going to be the length, breadth and height of this cuboid. Okay, this cuboid, okay, this is going to be melted, and what they are doing here, it is going to be recasted into spherical balls of radius 3 millimeter. Okay, note this, this is 3 millimeter. Okay, yes. Now if this is done such a way, then find the number of spherical balls formed. This is what we have to find here. So that means they are taking a huge cuboid, they are melting it and recasting into small spheres. Okay, yes. Now this is a problem based on transforming the solid shape. Okay, yes. Now whenever you get questions like this, what we basically do is we'll have to equate the volumes, because the total volume what is originally been there, that is what is transforming into another shape. So both the sides the volume will be same. So in this case what happens is the volume of the cuboid will be equal to this will be equal to that side, right hand side, they are transforming into, recasting it into spherical balls. Okay, fine. So spherical balls means you have to consider all the balls. So this will be equal to the volume of all those spherical balls, but we don't know how many spherical balls are formed. So let's do something. Let's take the number of spherical balls to be n. So n into volume of each sphere, okay, because since all of them are going to be of equal size, so I'm taking n into volume of one sphere. So this way if I equate, it will be easy for me to calculate the answer. And it should be noted that the volume formulas for cuboid is going to be length into breadth into height, we know it very well. And for a sphere the volume is going to be 4 by 3 pi r cube, where r is the radius. Okay, fine. Now one more point here we need to be careful is that for our cuboid, the measures are given in terms of centimeters, but for the sphere, it is given in terms of millimeter. So we should be knowing another thing also. 10 millimeter. Okay, so let me write it clearly. Yeah, 10 millimeter is equal to 1 centimeter. So which means 1 millimeter will be equal to 1 by 10 centimeter. So this alone we should be knowing. So when I come here, I have 3 millimeter. Now this 3 millimeter can be written as 3 by 10 centimeter. That's it. Okay. So why we are doing this is so as to make all the dimensions and with uniform units. That's why we are doing this. Okay. Yeah, fine. Now coming back to our equation, here the volume of cuboid will be nothing but L into B into H. We are expressing everything in terms of centimeters itself, so note it carefully. So left hand side I will have 9 into 11 into 12. Now this will be same as, come to the right hand side, I have n into, n stands for the number of spheres formed, n into 4 by 3 into because the volume of sphere is 4 by 3 pi r cube, 4 by 3 into pi, I am taking it to be 22 by 7 into, what about r here? R is what just now we transform. Okay, r we took it as 3 by 10 into 3 by 10 into 3 by 10. So we should be very clear that we are taking the units carefully on both the sides. Okay, now all we need to do is we need to simplify both the sides to get the answer. So how we can simplify this is, let's carefully simplify the numbers. First I will take the right hand side, I can cut one of these 3 with these 3's. Okay, this 3 with this 3. And what next I can do is I can also cut 4 3's are with this 12. Simple. Okay. And what next also I can do here is I can basically cut this 11 with this 22 for 2 times. Okay, fine. Yes. So anything else we can do here? Yeah, we can also do cut this 3 with this 9 for 3 times. Okay, fine. So that means my left hand side I am left with only 3, and my right hand side I have n into, my numerator contains only 2 divided by, my denominator is contains 7 into, okay, I'll have to put a big by, 7 into 10 into 10 into 10. So this is what we can do now. And also what I can do here is, okay, let me adjust, n is basically equal to, bring this fraction to the other side, so that we'll be getting 3 into 7 into, this is nothing but 1000 divided by 2. So I have n is equal to 21 by 2. So 3 sevens are 21. 21 by 2 will be like 10.5. 10.5 into 1000. So 10.5 into 1000 will be like 105 followed by 2 zeros. That's it. Okay. So that means I hope it is clear to you. So I have to move 3 decimal places. That's what I'm doing here. Okay. 1 place and 2 more places for this 2 zeros. That's it. Okay. So 10,500. No units, because we are finding only the number of spheres here we are forming, so number of spheres will be just a mere number. It's going to be just a number. So yeah, so we equate the volumes of the two shapes, and from there what we do is we use the formula and then we calculate the value of n, which stands for the number of spherical balls formed here. So n is going to be 10,500 is the answer for your question number 14. Question number 15 with us. Monica has a piece of canvas whose area is 552 meters square. So that is the material she is having. She uses it to make a conical tent with a base radius of 7 meter. So she is trying to make a conical tent. Okay, so that means the shape which is formed is going to be a cone, and they also mentioned that the radius of this cone is going to be 7 meters. Okay, please take a note of it. Yeah, assuming the wastage to be 2 meters square. So after all the works and completing the works, if the wastage is going to be 2 meters square, okay. Now what do you mean by this wastage is 2 meters square, which means out of the total material 552 meters square, this 2 meters square is going to be wasted. Only the remaining material is going to be used. Okay, that's the idea. Then find the volume of the tent that can be made with it. This is going to be the question. Okay, yes. So first of all, I need to be clear with in what way this area will be used. Now she is going to construct a conical tent, which means this area what she is using to construct will correspond to the curved surface area of this cone. Okay, so it corresponds to the CSA. We know CSA is going to be what? Pi RL for a cone. CSA is pi RL. Now pi RL is going to be what is the answer? It's going to be nothing but this 552, but when you exclude the wastages, it's going to be -2. Okay, yes. Now let's carefully do this. So this will imply what? Pi is going to be 22 by 7 into R is already 7 into L is going to be right hand side. I will be having 552 minus 2, which will be exactly 550, right? So now I can cut this 7 and 7. So L will be nothing but 550 by 22. 550 by 22 will give me 25. So I got L to be 25 meters. Okay, yes, success. So already our radius is 7 meters and now we got L is 25 meters. Now we need to find what? We need to find the volume of the tent. Okay, that means we need to find the volume of the cone. That is my question. So volume of the cone is going to be 1 by 3 pi r square h. That means we basically need the value of this height of this cone, right? Now see here, I have the values of r, radius and L, slant height. Now with this, how can I find the h value? I mean the height of this, vertical height of this cone. Again we need to use Pythagoras theorem only. Okay, so let's try to use Pythagoras theorem quickly. So I think I can use in this space. We have got enough space here. R square plus h square is going to be L square, which means I will be getting R square, which means 49 plus h square is what I need to find. This is equal to right hand side L square. L square is going to be 25 square and that is going to be 625. So that means I will have h square is equal to 625 minus 49, which will be 625 minus 25 will be 600, minus 25 will be 575. 575 plus 1 will be 576. So I got h square is equal to 576 and h is equal to exactly square root of 576. So you remember 24 square is what is 576. So h is going to be 24 meters. Success. We got the value of height also. Now all we need to do is find the volume of the cone. So this will be equal to 1 by 3 into pi is 22 by 7 into. Now what about r square? R square is going to be, yes, 7 into 7. And finally what about height? Height will be equal to 24. That's it. Okay. Yes, we got all comfortable numbers. Now I can quickly cut this 7 and 7, this 3 and 24. 8 times, so I will be having 22 into 7 8s are 56. So this will be nothing but 11 into 112. Why? Because I am taking a 2 and multiplying here. That's what I am doing. So now I can easily multiply this 2 plus 1, 3, 1 plus 1, 2 and finally 1. So 1232 meter, right? Because all the units are measured in meters. So the volume what I will be getting will be in terms of meter cube. So volume of the cone which is made is 1232 meter cube is going to be the answer. So 1232 meter cube is going to be the volume of the cone, and that's going to be the answer for your question number 15. Number 16, the volume of a conical tent formed is 1232 meter cube and the area of the base is going to be 154 meters square. Okay, yes. Then calculate the following things. One is we need to find the radius of this cone. Okay, that means the radius of the cone's floor which is formed. Okay, now if you see about the base of this cone, it is going to be what? It's actually going to be a circle. So area of the base they gave it to be 154 meters square, means the area of the base circle is what is going to be 154. So area of the circle, okay, the circle area is what is going to be 154 meters square. This is what we need to clearly understand. And what about this area of the circle? It's going to be pi r square, which is what is 154. Now if we solve for this equation itself, we can get what is the radius of the cone, right? So now pi is 22 by 7 into r square is equal to 154. That means now I can cut this 22 and 154 for 7 times. I get r square is equal to 7 square. So that means r is equal to 7 meters. That's it. We got what is the radius of this cone. Finished. 7 meters. Now coming to the height. Now to find the height, what we can use? We can now use the volume formula. Okay, now we know clearly that volume of a cone is going to be what? Volume is going to be 1 by 3 pi r square h, and this is what is equal to 1232. Clear? Yes, fine. Now let's do a very clear calculation. Now from this I got to understand that 1 by 3 into now look at this, this is pi r square. Pi r square is already, we know, it's going to be 154. So 154 into h is what is equal to 1232. Now when I simplify this, I can easily get the value of h. Okay, I don't want to do the calculation from the beginning once again. I can clearly do it this way. I can get the answer. So h is equal to 1232 multiplied by 3 divided by this 154. Now I can simply finish my calculation like this. So h will be equal to, now first of all let's try to simplify here. So I can cut with 11 tables, right? So 11 tables means it will be 14 times, and here if I cut with 11 tables, I will get 11 ones are 11, balance 1, 11 ones are 11, balance 2, and 11 twos are 22. Fine, yes. Now I have 14 and 112. So 14 and 12, 112, it will be exactly 8 times. So that's it. So now 8 threes are 24 meters. This will be the height. So we can easily, we're able to solve this problem very easily, right? And of course, if you have a close observation, this is nothing but the data exactly matches with the previous question, nothing else. Okay, so there also, if you come to check about the height and radius, so you will get the same answer, and this is the final answer what we got there in the previous question. So yeah, fine. So that we are easily finishing off. So the radius is 7 meter and the height is going to be 24 meters. So these are the answers for your question number 16. Seeing there's a third subdivision also there for this question number 16. Length of the canvas required to cover this conical tent, if its width is 2 meters. So we need to find the length of the canvas that is required to construct the tent. Okay, now if at all we need to find the length of this canvas, we need to first of all find out the total area that we need to build up this canvas. So that will be nothing but what? It is nothing but the curved surface area of that conical tent only. Okay, so we need to find the CSA of the cone. So CSA of the cone is going to be pi RL. Anyways, we already got the radius and height of this cone. Radius is 7, height is 24, which means what about the value of L? How we can find the value of L? L square will be nothing but R square plus H square. So L square will be equal to R square means which will be 7 square and H square is 24 square. So this will be 49 plus 576. So this will be nothing but 625. So L square is 625, which is 25 square. So L will be 25 meters. Okay, so L value is 25 meters. Now we got it ready. Now we will substitute it here. So pi is 22 by 7 into R is 7 into L. Just now we got it to be 25. So now this will stand for the curved surface area. So this will totally give you 22 into 25, because I can cut this 7 and 7. 22 into 25 will be nothing but 500 plus 50, which will be 550 meters square. So this will be the total built up area or material we need to we require to just construct this canvas. Okay, yes, but we need to find out the length of the canvas. So how we can find the length of the canvas? If this is the total area, and if at all I need to find the length of the canvas to construct the conical tent whose width is 2 meters, so what I can do is I can simply divide the CSA by the width. That will give you the length. So CSA is 550 divided by width is, you have it in the question itself 2. So now when I will divide it, I will be able to get the answer. So 550 by 2, it means 550 half. 250 plus 25, okay, 275 meters. So this will be the length of the canvas required to construct the area, and by this we are completing the third subdivision also, and the answer for this third subdivision is 275 meters is going to be the answer for your 16th question, subdivision number 3. We move on to question number 17. Find the radius and curved surface area of a cone which is made from a quadrant of a circle whose radius is 28 centimeter. So now there is a circle. There's a circle of radius 28 centimeter. So let me quickly draw it. So this is going to be the full circle. The radius is 28 centimeter. And you have to first of all consider the quadrant of a circle. Quadrant means just a quarter portion of this circle. Okay, yes. So when I have it, this is how it will be looking like. Okay, you just forget about the other remaining parts, only this quarter portion alone you just concentrate it. Okay, now for a better clarity, I just got one quadrant here which looks exactly like this. Okay, yeah, I think you can now just compare it. Okay, so now this is going to be the quadrant of a circle. Okay, if I open it, you will get a full circle. Okay, I'll open it and show you. Yeah, this is a full circle. Yes, and I'm just forming a quadrant here. Okay, the quarter portion of the circle, only this part. Now once again what you form is you are just going to form a cone from this quadrant of the circle. Okay, remember the radius is going to be 28 centimeter of this circle. The radius is 28 centimeter. I mean this quadrant also, the radius is going to be 28 centimeter. So that means this measure is 28 and this measure is also 28. Okay, please remember that. Now I'm going to just fold this quadrant and I'm going to form you a cone structure like this. Okay, now see here, you are forming a cone. Now you formed a cone here. Okay, this is how your cone looks. Okay, yes, now you can see a cone structure formed here. Okay, now for this cone only we have to form what? We have to find the radius and the curved surface area. Okay, yes, now these two things I have to find out. Radius means the radius of this quadrant is already available, but we need to find here the radius of this circle, which is, I mean the cone which is formed, that we have to find. Okay, so we need to find the, for the cone we have to find out the radius and also the curved surface area. Both these things we have to find it. Okay, yes. Now first of all, let us carefully look at the measures of this cone, how it is formed. Okay, now I wanted to look at this structure very carefully, this shape very carefully. Now when you see this, originally this is a quadrant, and for the quadrant these portions are going to be the radius, this and this is going to be the radius. Now look what happens when I fold it and form a cone. Now what happened to the radius? Just listen very carefully. Now what happened to the radius? Now the radius of the quadrant is what? Now became the slant height of this cone. Do you agree with this? Yes or no? Yes. So that means radius of the quadrant is now same as the quadrant of, I mean the slant height of this cone. Okay, please have this link. Now you'll be easily able to recognize and understand it. Okay, yes. And point number 2 is when I open it as it is originally. Now what about the area of this quadrant? Now this area of this quadrant, when I open it in a plain way, this looks like the area of this quadrant. Now when I close it and form it as a cone, now the same area of the quadrant now becomes what? Now becomes this area, I mean the curved surface area of this cone. Okay, yes. So these 2 points we need to be very carefully understanding. Okay, these are very important points here. So let's just quickly, I will make it for you. I'll write it here. So 2 things we saw here. One is, what is the thing is, one is the radius of the quadrant. Okay, so the radius of the quadrant is same as what? The slant height of the cone. Okay, the slant height of the cone, slant height of the cone, And point number 2 is, okay, this is first point, and point number 2 is what? Point number 2 is, next also we saw about the area of the quadrant. Okay, area of the quadrant is now same as the CSA of the cone. CSA of the cone. Okay, so these two things we have to be remembering very, very carefully. Okay, yes. Now why I gave this is, now see here, now I have to find the CSA of the cone. Okay, yes. Now CSA of the cone, just now we saw it is nothing but, the CSA is nothing but the area of the quadrant. Now area of the quadrant we can easily find it. Now this is going to be the quarter portion of a circle. So area of the quadrant will be now nothing but area of the quadrant is going to be nothing but, this is equal to 1/4 of the area of the square. Okay, so that means 1/4 into pi r square. So 22/7 into, now what about r square here? R square is going to be 28 square only. So 28 into 28, is it or not? This is what we will be getting. Now I can directly cut this, 4 sevens are for one of this 28. So now I will be having 22 into 28. So 22 into 28 will be same as, so this will be nothing but 280, 560, and then 56. So I will be getting 616 centimeters square. So this will be the CSA of this cone formed. Okay, because the area of the quadrant will be same as the CSA of the cone. So CSA of the cone is what we got it to be, 616 centimeters square. That's it. Okay, yes. Now the next thing we have to find is about this radius of this cone. Radius we have to find. Okay, yes. Now radius means, once I form it as a cone, the base, what is formed here? The base which is formed here, no. Okay, let me make it clearly. Yeah, the base what you see here, for this base circle form you will have a radius. That radius is what they are asking here. Okay, yes. Now how we can find this? So how we can find it is, now also let us use the formula of this, what to say? Okay, let me write it clearly. Yeah, now also I can make use of the formula of this, CSA of the cone itself. Okay, now why? Because CSA of the cone, if you see, it is going to be pi RL. Now pi RL is what is, we got it to be 616 centimeters square. Okay, now already we know what is pi. Pi is going to be 22/7. Now r is what I need to find. And what about this L value? L means the slant height of the cone. So what about the slant height of the cone? It's nothing but the radius of the quadrant itself, right? Okay, so radius of the quadrant itself means it's going to be 28 only. So now, so I will take this L as 28. Why? Because this L is nothing but this L. So when I fold it only, I am forming this L. Okay, so this is what is L. That was originally the radius of the quadrant. That is what is 28. So I am noting it. So this is equal to 616. Now when I solve this itself, we can easily get the value of r. So now what I can do here is, I can cut this, basically this, 7 and 28 for 4 times. So r will be equal to 616 by 22 into 4. So already 616 by 24, it is going to be like, 28 times, and 28 I can cut with 4 for 7 times. So radius is equal to 7 centimeter. That's it. Okay, yes. So successfully we got both the values. So cone, for this cone formed, the radius is going to be 7 centimeter, and for the same cone, the CSA is going to be 616 centimeters square. And these are going to be the answers for your question number 17. Next we have question number 18 with us. A hemispherical dome of a building needs to be painted from outside. So there is a hemisphere shaped dome is there at the top of a building, and they have to paint it, the outside surface. If the circumference of the base of the dome is given to be 17.6 meters. Okay, so let's take a note of it. The circumference is going to be 17.6 meters. Remember, they gave the units in terms of meters. Then what we need to find is, find the cost of painting it at a rate of rupees 8 per 100 centimeter square. So the cost is going to be, okay, let's note the cost separately here. So the cost is going to be rupees 8 per every 100 centimeter square. Okay, let's clearly note this. So they gave the cost in terms of centimeter square. This much rupees in terms of centimeter square they are given. Okay, yes. So now this is going to be the data. We need to get the approach to find the answer. Let's do it carefully. Now start from here. Circumference of this hemispherical base is going to be 17.6 meter. First of all, we will convert this to centimeters. So this will be nothing but 17.6 into 100, because we know 1 meter is 100 centimeter, correct? So 17.6 into 100, this will be nothing but 1760 centimeter. Is it or not? Yes. Okay, yes, fine. Now the idea is clear to us. Now the next thing is we will just try to find the radius. Why? Because circumference of the base is nothing but 2 pi r. So 2 pi r is what is equal to this 1760, which means I can substitute the values. 2 into pi 22 by 7 into r is equal to 1760. Yes, fine. Now I can cut this 2 and this 1760 for 8 times 2 6 are 18, again balance 1, 2 6 are 8, 2 8s are 16. Okay, yeah, 2 8s are 16, again 2 8s are 16, 880. So we get this 880 times, and once again I can cut with 22 and 880 for exactly 40 times. So that means I will be getting r is equal to 40 into 7, which will be 280 centimeters. Okay, remember the radius value what we get will be in terms of centimeter only. Why? Because here itself we converted the circumference to centimeters. The answer will also be in centimeters only. But we need to find the cost. For the cost, for what we need to find? We need to find the cost to paint the outside surface. Now the outside surface of this hemisphere is going to be the curved surface area, is it or not? So which means I need to first of all find out the CSA, curved surface area. So curved surface area is going to be what? 2 pi r square. Okay, yes. Now next is what I need to do. What? I need to find the cost. Now to find the cost, what I have to do? I have to take this 2 pi r square. I need to multiply this with our cost per unit. So cost per unit is going to be 8 rupees for every 100 centimeter square. We need not worry about it because this 2 pi r square's value what we will be getting itself will be in terms of centimeter square only. So I can directly multiply that with 8 by 100. Okay, yes. Now let's substitute the value 2 into. Now what about pi? Pi is 22 by 7 into. R square means I have to do 280 into 280 into, once again I have to multiply by 8 by 100. Correct? Okay, yes. So let's carefully do this calculation. We will be easily able to get the answer. So first of all, I will do 0 0. I'll cut the zeros and zeros with these two zeros. Next, what I can do is I can cut this 7 and this 28 for exactly 4 times. I can do this, so that now I will be having 2 into 22 into 4 into 28 into 8. So this is all I will be having. Okay, yes. Now what next I can do is I can multiply the values carefully here. So once I do it, I can easily get the answer. So how we can multiply is, okay, yes, first of all I will just take this 22 into, this is 2 8s are, sorry, 2 4s are 8, and then I will have 8 8s are 64 into, once again 28. Okay, yes. Now once again I will just take this 22 as 11 into this 64, I will keep it as it is, into this 28 I will make it as 56. Okay, I'm just getting half of 22 11 and I'm doubling this 28 56. So 11 into 64 into 56. The reason why I made like this is, now this will be easy for me to calculate. So 11 into 64 into 56. So 64 into 56 will be like 60 plus 4 multiplied with 60 minus 4. Is it or not? Correct? Yes. Okay. Now this can be done very easily. This is nothing but 60 square, 3600 minus 4 square, 16. So I will have 3600 minus 16. So this will be nothing but this answer only. So 3584. Now finally I have to multiply this to get the answer. It will be rupees. So 11 into this number only we have to do, right? So we can easily do it. Start from the last place, units place. It will be 4. 4 plus 8 will be 12. So put the 12, take the 1 carry. 8 plus 5 will be 13. 13 plus 1 will be 14. Take the 1 carry. Again 3 plus 5 will be 8. 8 plus 1 will be 9. And then finally take this 3 also. So this 39424. Yeah, okay, yes, we are finishing this. So I hope the way how we are getting the answer is clear to you. First we solve for the radius, and then from there we find the curved surface area of the outer surface of this hemisphere, and then from there we find the cost. So rupees 39,424 is going to be the answer for your question number 18. Moving next to question number 19. Two solid spheres made of the same metal have weights 5,920 grams and 740 grams respectively. So there are two solid spheres and they are also made with the same metal, and for which only they have given the weights. Okay, yes. Now we have some property to be discussed here, but let's finish off the question first of all. Now determine the radius of the larger sphere if the diameter of the smaller sphere is 5 centimeter. So they are given the diameter of the smaller sphere, and what we need to find here is we need to find the radius of the larger sphere. So it is very clear that in this question there are two spheres. One is the larger sphere, and the other one is the smaller sphere. Let's clearly note this. And one more thing is we got to know the diameter of the smaller sphere also. Okay, so the diameter is going to be 5 centimeter, which is given in the question. And from this itself we can clearly tell the radius is going to be 5 by 2 centimeter. Okay, yes, let me not write it in decimals, I'll have it as a fraction itself. And what we need to find here is we need to find the radius of the larger sphere. That's the question. So let's take the radius of the larger sphere to be some x centimeter. Okay, same units, that's the reason. Okay, yes. Now let's go back to the first statement which is given in the question. We have these two spheres made with the same metal. So that means what we can clearly understand is the density of both the spheres are going to be the same. Is it or not? Yes, fine. Now in that case, we can easily relate the volume of these two spheres with the weights of the two spheres. Okay, how we can relate? They will be directly proportional. They will be proportional to each other. Okay, yes, like we can clearly derive a relation here. Just listen to it carefully. What I can do is, how I can relate is, I can first of all take the volumes of these two spheres. Okay, volumes will be like volume of the larger sphere divided by the volume of the smaller sphere will be same as. Now come to the right hand side. Right hand side I can compare their weights. Weight of the larger sphere divided by the weight of the smaller sphere. I hope the relation is clear to you, right? Yes. Now all we need to do is just substitute the values and get the answer. Now start from here. What about the volume of the sphere? Volume of the sphere, we know the formula 4 by 3 pi r cube. That means 4 by 3 pi. What about the volume of the larger sphere? We took it to be x centimeter. So x cube divided by volume of the small sphere will be 4 by 3 pi. What about the radius of the smaller sphere? That is going to be 5 by 2 centimeter. Okay, so 5 by 2 cube. Okay, yes, since both are in centimeters, our units will also be adjusted. Now this will be same as, now come to the right hand side. What we have, I have their weights given in the question itself. So weight of the larger sphere is 5920 grams divided by, and what about the weight of the smaller sphere? That is going to be 740 grams. That's it. Now we got a clear relation. Now when we clearly solve this relation itself, we can easily get the answer to the question. Okay, yes, fine. Okay, let's do this carefully. I'll put a line here. So first of all, on my left hand side I can cut this 4 by 3's, this pi's. Okay, now what else I can do here is I can take x cube divided by, this is going to be 5 by 2 the whole cube, right? Okay, yes. So 5 by 2 the whole cube is actually going to be like I will better have it as 5 by 2 the whole cube itself. I have a reason. Now this will be same as, come to the right hand side also we can simplify it here. So I will cut this 0 and 0, and next I can cancel these two numbers, 592 by 74. If you clearly see this, it's exactly 8 times. Is it or not? 74 into 8, you check it. 74 8s are, you will be getting 5632, 592. So I will have 8 by 1 on my right hand side. So this will be same as 8 by 1. Okay, yes. Now let's have a clear look here. So this is going to be nothing but, this 8 is nothing but 2 cube divided by this 1 is nothing but 1 cube. The reason why I am writing this is both the sides I am expressing in terms of cubes. That's why. Okay. Now left hand side again you come here. I will have x by 5 by 2 the whole cube is same as, right side I have 2 by 1 the whole cube. That's it. This is the simple idea. Now we can very easily solve it. I can just take cube roots on both the sides. I can cut these numbers. So I will be having x by 5 by 2 is equal to, right side I simply have 2 by 1. Which means from this we will be getting x is equal to 2 into this 5 by 2. So this will give you x is equal to, I can cut this 2 and 2, 5. So 5 and in centimeter. Okay, yes. That's it, very simple. So when we carefully deal with the operations and numbers, we can easily get the answer without going for any complicated steps. So that's what we are trying to do here. So yeah, that means the radius of the largest sphere, it's going to be 5 centimeter is going to be the answer for your question number 19. Moving next to question number 20 here. The water for a factory is stored in a hemispherical tank whose internal diameter is going to be 14 meters. So there is a hemisphere shaped tank and you have the diameter of the tank given to be 14 meters. So let's note it, diameter 14 meters. So that means what about the radius you can tell? 14, half of 14 which will be 14 by 2, 7 meters. So this will be the radius. Okay, now you see here the tank contains 50 kiloliters of water. So already the tank contains 50 kiloliters of water. Water is pumped into the tank to fill to its capacity. So now they are completely filling the tank. Now finally what we need to find is find the volume of water pumped into the tank. Now extra water we are going to fill it, right? So to fill it up to the capacity, how much extra water we need to fill it there? This is going to be the question. And note the point that the tank is already filled with 50 kiloliters of water. Now to solve this problem, what are all the things we should be basically knowing regarding the units is 1 kiloliter is going to be 1000 liters. And we already know that 1 meter cube of volume is also equal to 1000 liters. So from this, when you connect both the things, from this what you come to learn is 1 meter cube is same as 1 kiloliter. That's it, okay? So this part we should be knowing. 1 meter cube and 1 kiloliter is going to be equal. Yes. And next is the hemisphere. Volume of the hemisphere is going to be 2 by 3 pi r cube. This formula also we should be knowing in order to solve this problem. Now we are ready with all the things whatever we want. Now let's try to get the answer. So it's going to be very clear. We'll try to do it in one single step itself. Now listen very carefully what I'm going to do. Now the volume, how much we need to pump, that's what is they're asking here. Okay, so volume of water to be pumped. Okay, so the pump volume will be nothing but the total volume. Okay, I mean the total volume means the volume of the hemisphere. Now from this, now what I have to subtract it, I need to subtract the volume of water which is already there. Okay, now see here, already there is 50 kiloliters of water. So 50 kiloliters, I will write it as 50 itself. Why? Because you will see carefully here. So we already have the relation, right? 50 kiloliters is, and I mean like 1 meter cube is 51 kiloliters means 50 kiloliters is going to be same as 50 meter cube. Okay, that's the reason. So I'm considering like this itself. So I'm going to express the volume now in terms of kiloliters itself so that I can directly get the answer. That's the reason. So now continue the problem. Volume of the hemisphere is going to be what? 2 by 3 pi r cube. So 2 by 3 into pi is going to be 22 by 7 into, what about r? R is going to be 7. So 7 into 7 into 7. Remember minus 50. Remember here the answer what we get will be in terms of meter cube only, but it is of no problem. Why? Because whatever meter cube I get here as the answer, the same is going to be in terms of kiloliters also, because 1 meter cube is 1 kiloliters. So this many meter cube will be same as this many kiloliters. That's a simple idea behind it. Okay, yes. So I don't want to adjust anything here. Don't want to change any units here. Since fortunately 1 meter cube is 1 kiloliters, I'm using the same here to give my answer in terms of kiloliters itself. That's why. Okay, yes. Okay, now what next I can do is I can cut this 7 and 7. So next I can do 2 by 3 times of, now let's try to multiply these numbers, 22 into 7 into 7. So I will be getting 22 7s are 154. Next 154 into 7 also we will do it here. Okay, 154 into 7 will be nothing but, so 4 7s are, it will be 28. I'll put it directly here. 4 7s are 28, 2 is the carry. 7 5s are 35 plus 2 37, 3 carry, and then 7 1s are 7 plus 3 is 10. So minus 50. Now we have to carefully calculate 2/3 of this 1078. Okay, so 2 by 3 of 1078 will be nothing but, first I will divide this value by 3. Okay, so 1078 I will divide it by 3. So what space I can take? I can take this space is enough. Okay, by 3 if I want to divide, it will be 3 3s are 9, balance will be 1. Okay, so 17, 3 5s are 15, so then 28, 3 9s are 27, and so balance is 1. So point I will be having 3 3, correct? So I will have uh, 2 by 3. First I'm dividing by 3 is what I got this. Next I will multiply this value itself by 2. Why? Because I have to multiply by a 2, that's why. So I will have 359.33. So 359.33 into 2 will be nothing but, my answer will be in terms of 66. Okay, this 50 minus 50 I'm putting it here. 0.33 into 2 will be 0.66. Now this one I have to multiply by 2. So 359 into 2 will be basically, 359 into 2 will be 700 plus an 18. So 718.66 minus 50. So now when I minus this 718.66 minus 50, if I minus, I will be getting 700 means 650. 650 plus 18 will be 650 plus 18 will be 668, 668.66. Okay, yes. So 650 plus 18, 650 and 18 will be 668 only. Yeah, it's perfectly right. 668.66 approximately. That's going to be the approximate answer. So 668.66, and remember the answer what we will be getting will be in terms of meter cube, and also it is same as kiloliters. Okay, so this many kiloliters. So finally 668.66 kiloliters of water is what is need to be pumped into it to fill the tank up to its capacity. So 668.66 kiloliters is going to be the answer for your question number 20. We next have question number 21, a very interesting question. A cone of maximum size is carved out from a cube of edge 14 centimeter. So now you can look at this figure what I've drawn here. This is how it looks. You have a cube here, and this cube's edge is given to be 14 centimeter, which means like the length, breadth and height is going to be, each of which is going to be 14 centimeter. That's what is they gave here. And what they are doing here is they are just going to carve out, cut and remove out a cone from this of maximum size. Now how can you remove a cone with this which is of maximum size from this cube? So it's very clear. If at all you need to do this process, the cone's base should be a circle of maximum size that will suit with the base square of this square, I mean this cube. Okay, yes. So which means I can clearly understand that the base of the cone should also have a diameter of 14 centimeter, which is matching with this side of this cube. Okay, which means if this diameter is also 14, then I can tell the radius of the base of the cone should be equal to 14 by 2, which is going to be 7 centimeter. Okay, all right, yes. So let's note it. For this cone, the radius is going to be how much? It's going to be 7 centimeter. And next is the height. Okay, we'll have to talk about the height of the cone also. You see, this is the height of the cone. Now what can I tell about the height? So if at all I need to remove a cone of maximum size, the height should be exactly matching with the side of this cube, is it or not? Which means the height of this cube should be same as the height of the cone. That means very simple, the height of this cone should be also 14 centimeter. Okay, now these are the two important things you should be knowing. So cone's radius is 7 centimeter, height is 14 centimeter. Okay, yes. Now what we need to find here, that is also important, find the surface area of the cone. That is, we need to find the surface area, that is the total surface area of the cone, and also we need to find the total surface area of the remaining solid which is left over. That is, once after removing the cone's portion from this square, I mean this cube, you will have the remaining solid left over there, right? For that solid also we are supposed to find the total surface area. So these two things are what we need to find here. Okay, yes. Now to solve this problem, what are all the formulas we require is, we need to know the total surface area of a cone. Basically it's going to be pi r into L plus r, where r is the radius, L is the slant height. And also we need to know the total surface area of a cube, which is going to be 6a square, where a represents, where a is going to be the side of the cube. That's it. Okay, yes. Now coming back to our problem, we should basically find out the value of L here. L is important, so L is going to be what? L is going to be square root of what? R square plus H square, right? So 7 square plus 14 square. Let me make it very simple. Let me not complicate it. So I will remove a 7 square outside. It comes there as 7. So inside I will be having what? Inside I will be having 1 square plus 2 square. I hope you understand that. If I remove a 7 square outside, I will have a 1 square here. I will have a 2 square here. So 1 square plus 2 square will be nothing but 1 plus 4, which will be 5. So 7 root 5 centimeter. That's it. Make it simple. So this is going to be the value of the slant height, I mean L, of the cone. Okay, yes. So let's find out the answers one by one very clearly. First, we will find out the total surface area of the cone. Okay, so TSA of the cone, we will find it out. So this will be nothing but we have the formula ready available with us. Pi r into L plus r. So pi into, what about r here? R is going to be 7 into L plus r. So what about L plus r? L plus r is going to be, so first of all I can even take the value of pi as 22 by 7, right? Yeah, 22 by 7 into L plus r. L plus r means L is already 7 root 5 plus r is going to be what? R is going to be again 7. Okay, yes, fine. So that means I can cut this 7 and 7. I will be left with I will be having 22 into 7 root 5 plus 7. Okay, yes. So this is what I will be having, and if at all I can even take the 7 as a common factor outside. So when I take the 7 common outside, I will have 22 into 7 into root 5 plus 1 alone will stay inside. So 22 into 7 will give you 154 into root of 5 plus 1. So this much centimeter square is going to be the answer for your total surface area of the cone. So this we completed in a very plain way. This is done. Okay, yes. Now next is we need to find out the surface area of the remaining solid which is left over also. Okay, so the surface area of the remaining solid also we have to find it very carefully. Now how we can find it, that is what is important. We need to carefully look at and observe this given solid figure which is left over after removing the cone outside. Now basically we had a cube. Now cube surface area is 6a square. Let's note it, 6a square. Now from this, what actually we are doing is we are just going to remove what? We are just going to remove the base circle. Okay, yes. Because when I remove the cube, what happens is the base circle gets removed. Okay. Remember, these 4 other remaining spaces that you see in the base will stay there as it is. That will not get disturbed. So out of the 6a square, this base area will be getting removed, which means I have to remove a pi r square. Understand? Because the base circle gets removed. And what happens next is we have another inside surface created there. What about that inside surface? We have a pit kind of thing just created there. Is it or not? That will happen when you remove the cone outside. Now see here very carefully. Now what can I tell about the pit that is formed inside? What happens is when you invert it and see, you will have a pit inside. Now what can I tell about the pit region that is formed there? That will be nothing but the curved surface area of your cone. Okay, that means additionally a curved surface area of the cone will be formed there. Now what about the curved surface area of the cone? That will be nothing but pi r l. So this calculation, if you do, this will tell you the total surface area of the remaining solid which is left over. So now let's carefully solve for this. We will be able to get the answer. Now start from 6a square. 6a square means 6 into what about a? A is what is this? 14. Okay, so a is 14 centimeter because a is the side of the cube. So 6 into 14 square minus. Now what about pi r square? That will be 22 by 7 into. Now what about r square here? R square means the radius of the cone only. So 7 into 7 plus next, what next I have is pi rl also I have. So 22 by 7 into, again same, r is going to be 7 into, what about l? L is going to be 7 root 5. We already got it here, right? 7 root 5. Okay, let me put it here. Now let's carefully solve this. So first of all, 6 into 14 square is going to be 196, right? So 14 square is 196. So okay, I'll take this space itself. 196 into, I have to multiply it with 6. So this will be nothing but 200 into 6 will be 1200 minus 4 6 are 24. So I will be having 1200 minus 24. I hope you are able to understand what I am doing here. I am simply doing this 196 as 200 minus 4. First I multiply 200 into 6 is 1200, and next 4 6 are 24. I'm just doing this subtraction, so I will be getting 1176 here, minus this 7 and 7 I can cut it here, so 22 into 7 will be 154. And then next I will also have I will be also having this extra values, this 7 and 7 I will cut it, I will be getting 154 root 5. Okay, yes. Now when I carefully do this calculation, I will be getting what is 1176 minus 154. These two numbers I can first of all subtract. 6 minus 4 2, 7 minus 5 2, 11 minus 10 is 10. So 1022 plus 154 root 5. So this many centimeters square. Okay, yes. So why? Because like this is actually in a form of roots, right? You have a cert here, so I can simply leave it as it is. So this will give you the answer for your surface area of the remaining solid. So successfully we got the answers for both the questions. First question, what about the surface area of the cone? It's going to be 154 into root 5 plus 1 of centimeter square, this many centimeter squares. And for the next question, surface area of the remaining solid is going to be 1022 plus 154 root 5 centimeter square. So now these are going to be the answers for your question number 21. Next we have question number 22 with us. The figure of a rocket consisting of a cylinder that is surmounted by a cone at one end. So you can see the figure here. It's going to be a rocket, and it is actually what is, you have a cylinder, and above the cylinder they are attaching a cone. So one end of the cylinder they are just attaching a cone. So that is going to be the structure of this rocket. And next is they are given some information about the dimensions of this rocket. Common radius is 3 centimeter. So for this cone and also this cylinder, the common radius is 3 centimeter. Let's note it. Okay, so this is 3 centimeter. So this is also going to be 3 centimeter. Okay, next is the height of the cone portion is 4 centimeter. So cone's portion alone, the height is 4. So we'll note it 4 centimeter. And next is the total height is going to be 14 centimeter. Now what do I mean by total height? Total height means from here to here. Okay, so from the tip till the bottom, the total height is going to be what is 14 centimeter. That's what is they give here. So which means what we can clearly understand from here is the height of the cylinder will be, the cylinder's height portion will be 14 minus this 4, which will be 10 centimeter. Yes, done. Now what next is, if the model is drawn to a scale of 1:500. So now we have to clearly understand this. This is a model, okay, the model what they have drawn. So comparing to the original rocket, it is going to be of the ratio 1:500. That means what we can understand here is the original rocket is of going to be, the measures and dimensions are going to be 1:500 ratio. That means what we can clearly understand is these dimensions what you see are like 1 parts. The actual dimensions are going to be 500 parts, or otherwise I can tell the actual dimensions are going to be exactly 500 times. That is what they are giving here. Okay, yes. So yeah, okay, we'll clearly note it 500 times. So which means we can clearly just try to here itself we'll try to figure out the actual dimensions of the rocket. Now I have just written one by one, cone here and the cylinder here. First we'll start from the cone. Now what about this cone? For cone the radius is 3 centimeter, height is 4 centimeter. Now what can you tell about the slant height? Slant height means this L portion, that will be, we have to use Pythagoras theorem. When we use it itself, we can clearly tell root of 3 square plus 4 square, which is going to be root of 9 plus 16, root 25, which is going to be 5 centimeter. Okay, yes. Now all the model values are available with us. Now with this we will try to find out the actual dimensions. Okay, now start with cone. Cone is going to be radius is 3 centimeter. 3 centimeter means for this model it is 3 centimeter. Then for the actual, what about the actual the length, what we can tell for the actual thing, it is going to be how much? 3 centimeter multiplied by 500. Okay, each of these dimensions we have to multiply with 500. That's it. Okay, so 3 centimeter into 500 will give you 3 into 500, which means 1500 centimeter. Now 1500 centimeter means it's very clear that it's going to be 15 meters. Okay, fine, yes. And next is height. What about the height? Height of the cone portion is 4 centimeter. Just do 4 into that 500. Okay, fine. Yes. Or 4 into 500 will give you 200. So, sorry, yeah, 4 into 500 will be 2000, and that means I can just simply divide it by 100 to get it 20 meter. Okay, so this way we can find out the actual values. Or the other way to easily do is, anyways, we have all these values in terms of centimeter. I will simply multiply, instead of multiplying by 500, I will simply multiply by 5 itself. Why? Because we can directly get the answer in terms of meters. That's why. Okay, yes. Now coming to the slant height. What about L? Slant height is 5. Just do 5 5s are. 5 5s are will be 25 meter. Okay, so 25 meters. And next come to the cylinder part. Cylinder part radius is going to be what? It is going to be same as the cone's radius, which is going to be 15 meters. And last one, height of the cylinder is going to be, in model it is 10 centimeter. So 10 into 5 will be 50. So 50 meters. So now we are ready with all the actual values, actual dimensions of the rocket. Now what we need to find here, that we will think about it. Okay, we need to find two answers here. The first subdivision is asking for find the total surface area of this rocket in terms of pi meter square. Okay, remember we have to clearly do this problem in terms of meters only. Okay, now forget about the original dimensions, they are all with respect to the model only, but these are going to be the actual values. So with respect to these values only, we need to do the calculation. So first subdivision is asking for the total surface area. Now what about the total surface area of this object, this rocket? Let's carefully think about it. Okay, yes. Now this total surface area of this rocket contains actually the curved surface area of this cone, the curved surface area of this cylinder, and then bottom you have a circular surface, I mean the base. So the three surfaces available here. Let me repeat it. The curved surface area of this cone, which means it will be pi RL, then plus. Next come here, the curved surface area of the cylinder. Curved surface area of the cylinder is going to be 2 pi RH. So 2 pi RH plus. Last one, you have a base there. That base is going to be a circle, right? Which means pi R square. So these are the things you have here. Now when I simplify this itself, you will be able to get the answer. Remember, we don't have to express or we don't have to use the value of pi here. Pi, we will keep it as it is as pi itself. Okay, yes. So now what first thing I can do here is I will first of all take pi r as common outside. When I do it, I will be getting inside L plus 2h plus r. This is what I will be getting. Is it or not? Yes. So now this is again equal to, what about now this one? Pi r. Okay, so pi r means I will have pi into, what about r is here? R is 15 only, 15 multiplied by, now L is going to be 25 plus 2h. Okay, remember here this h stands for the height of the cylinder only, don't confuse it with the height of the cone. So 2 pi rh, from this quantity only we took the h r as common. So this 2h stands for, this h stands for the height of the cylindrical portion only. So 2h means I have to take this value only, 2 into 50, then plus finally r is again 15. Okay, yes. Now this will be equal to 15 pi into, now what about inside I will be having 25 plus 15 will be 40, 40 plus this will be 100, so 140, I will have 140. Okay, yes. So finally I will be having 15 into pi into 140, this is what I will be having. So now when I again multiply this, I will be getting what is, I will be getting 14 into 15. So 14 into 15 will be basically how much? 140, 70, 210. So I will be having 210 followed by a 0, and then I will have a pi. So 2100 pi meter square is going to be the total surface area of this object. Okay, is the rocket. And now moving to the total volume. Now how can you find the volume of this object? Volume is going to be very easy. Volume is actually the capacity only, right? So we can directly add the volumes of this conical portion and the cylindrical portion. We know the formulas for both the things. For the cone, the volume is going to be 1 by 3 pi r square h. Okay, maybe for differentiation I will just try to represent it as a h1. Okay, h1 means for the cone's portion is what is h1. Okay, then plus 1 by 3, I'm sorry, for the cylinder, right? For the cylinder, what about the volume? For cylinder the volume is pi r square h itself, pi r square h, but this height stands for the height of the cylinder. I will take it as h2. Okay, just to have a differentiation. So this is equal to, now once again I can do take pi r square as common outside. So pi r square, when I take it common, I will have 1 by 3 h1 plus here h2. This is what I will be getting. So what next I will have is pi into, what about r square? Now r square is going to be 15 square. So this will be 15 into 15 into now inside I will be having what? I will be having 1 by 3 into 1 by 3 into, what about h1 here? H1 is going to be actually the height of the cone only, right? So height of the cone means I will be having it to be how much? It will be yeah, 20. So this will be 20 plus next h2 is going to be the height of the cylindrical portion, which will be 50. Okay, yes. So this is what I will be getting. So now I will be having the answer to be equal to pi into 15 into 15. Now I will have this LCM here. Okay, yes, when I take the LCM, I will be having 1 by 3, 20 by 3. This will be 20 by 3 plus 50, which means when I take the LCM, I will have 3 here. So my numerator will become 20 plus 3 times of 50, which will be 150 plus 20, 170. Okay, yes. Now what next I can do is pi into, I will cut this 3 with one of these 15s to get for 5 times. So I will be having pi into 5 into 15 into 170. So this is what I will be having, pi into 5 into 15 into 170. So this is what I will be getting. So finally I have to solve for this. So how I can solve for this is like pi into, okay, I'll directly get the answer itself. So I will be having 5 into 15 itself will be 75. So 75. So I have to okay, here I have a space. So 5 into 15 itself is a 75. So 75 into, I will multiply with 17. So 75 into 17 if I do, I will be able to get the answer. So 75 into 17, how I can deal this is 75 into, first of all, 20 if I do, I will be getting 1500, and minus 75 into 3 will be 225. If I do this, I will be able to get the answer. So I will be getting 75, this will be 14, 12. So 1275, I will finally get 1275, but I have to follow by a 0 because I have a 0 here. Pi, the pi is also there, right? So pi meter cube. So this is going to be the total volume. So if you carefully see here, this is going to be the total surface area. Yeah, total surface area of this the rocket portion. So what is the answer? 2100 pi meter square is going to be the total surface area of this rocket portion, and 12,750 pi meter cube is going to be the volume of this rocket portion. And these are going to be the answers for your question number 22. Next we have question number 23. A toy is in the shape of a right circular cylinder with a hemisphere on one end and a cone on the other end. So now see here, this is how the toy looks like. You have a cylindrical portion which can be seen in the middle, and to its one end they are attaching a cone, the other end there is a hemisphere. So this is how it looks. And now let's see this. The height and radius of the cylindrical part are going to be 13 centimeter and 5 centimeter respectively. So what is it they are telling here? Now they are telling about the height and radius of this cylindrical part. Okay, so height is going to be 13 centimeters. So let's note it. So this portion is going to be 13 centimeter. Okay, so 13 centimeter, I'll note it here. Why? Because there are different heights available here. So as to not confuse only, I'm just marking it in the picture, the figure itself. Okay, let's continue. And also we have the radius is 5 centimeter. Okay, the radius is 5 centimeters. So this is 5 centimeter. This is also radius. This is also 5 centimeter. Okay, yes. And if you see this, it is very clear that the radius is going to be a common portion. Okay, because the radius appears to be the common in all these three shapes, which means for the conical part also the radius has to be 5 centimeter only, and the hemisphere also it is going to be 5 centimeter only, which means we can understand one more thing. For this hemispherical part, this height is also the same radius, which is 5 centimeter. Okay, all right, yes. Fine, let's continue the question. Yeah, okay. The radii of the hemispherical and the conical parts are the same as the cylindrical part. That's what they also mentioned here. Now, what we have to do is calculate the surface area of the toy if the total height of the conical part is going to be 12 centimeters. So that means for the conical, the conical height is going to be, the conical part's height is going to be 12 centimeters. So this portion they come to give it as 12 centimeter. Now we got all the things which are required for us to solve the problem. So we have clearly the data available with us. So for the cone, height is 12 centimeter. For cylinder, the height is 13 centimeter. For this hemisphere, the radius is 5 centimeter. And in fact, for cone and cylinder also, the radius is 5 centimeter only. Yes, fine. Done. Now, all the things are clear. Finally, what we need to find here is calculate the surface area. That means we need to find the total surface area of this solid. This is going to be the question. Now, it's very easy. To find the total surface area of the solid, we have to see physically what are all the surfaces visible available for this toy. Okay, yes. Now, if you clearly see that the physically seen surfaces are the curved surface area of this cone, correct? Which means that should be taken pi RL plus. Next, what about this one? Cylinder. For the cylinder also, the curved surface region is what is seen, right? Yes. Curved surface area of the cylindrical portion is going to be 2 pi RH and then plus. Now come last one, this hemisphere. For this hemisphere also, the curved surface area is what is, that surface is what is visible. So that hemisphere's curved surface should also be taken into account, which is going to be 2 pi r square. Yeah, these are all the things which we have to care about, because once we add these values itself, we'll be able to get the total surface area of this entire shape. And one more thing, we have to be very careful. These circular bases are available, right? We need not consider those circular regions, the areas. Why? Because those circular bases area will be fit inside itself. Okay, they will be hidden, they won't be visible outside. Only these three surfaces, curved surfaces, are visible. That's the reason to find the total surface area of this toy, we are adding these three surface areas. That's a simple idea behind this. Okay, now it is very clear that we have the radius, the height, everything is available with us. The only thing is this L, the slant height of the cone alone, we have to find it. Okay, so what about this L? L will be nothing but, it's very easy, square root of r square plus h square, which means square root of r square is 25 plus h square is 144, because this is 5 square 25, 12 square 144. So I will be getting square root of 169, which will be 13 centimeters. So L is 13 centimeter. Now we got L value also done, everything done. Now we will simplify it and to get the answer. So first of all, I can take pi r as a common value, right? Pi r, if I take it common outside, I will have L. Here if you take pi r common, you will have 2h having inside. And here also pi r, if taken outside, I will have 2r inside. Done. Okay, yes. Now we can substitute the values. Pi r will be like 22 by 7 into pi, I am taking this 22 by 7. R is what? R is common radius only. It's going to be 5 into what about L here? L is going to be 13 plus 2h they are given. Okay, so 2h means this h corresponds to the height of the cylindrical portion. Be careful here. So 2h means 2 into 13. Yeah, 2 into 13 plus. And what next about 2r? 2r will be 2 into, it's going to be 5 only, right? So 2 into 5. Yeah, yes. So now I think all the things which are relevant we have with us. So yeah, the things are all with us, I think, right? Okay, yes, let's see now what happens carefully. 22 by 7 into 5 into, now let's do this inside calculation, what we see inside the bracket. This will be like 13 plus 2 into 13, it's like 3 into 13. That means this is like 3 into 13. 3 into 13 will be 39. 39 plus, this is 5 2s are 10. So 39 plus 10 will be simply 49. So we made it simple. 22 by 7 into 5 into 49. So I can now cut this 7 and 49 for exactly 7 times. So I will be having 22 into 5 into 7. This will be like 110 into 7. So 770 is going to be the answer. And we will have the answer in terms of centimeter square. Since we are finding the area, total surface area, the answer what we will be getting will be in terms of centimeter square. So 770 centimeters square is going to be the answer for your question number 23. Next we have question number 24 with us. A girl fills a cylindrical bucket which is 32 centimeter in height and 18 centimeter radius with sand. So a girl is going to fill a bucket. The bucket shape is cylinder. They gave the height and radius. Now what she is doing, she is emptying the bucket on the ground and makes a conical heap. Now whatever sand she collected in the cylinder, she is going to pour it down to form a conical heap. That's what is happening here. And conical heap of sand. If the height of the conical heap formed is going to be 24 centimeter, that is the height of the cone she is forming is going to be 24 centimeter in the sense, then find these two things. What are the things we have to find? First, we have to find the radius of the conical heap, and second one is we need to find the slant height of the conical heap. So these are the two things we need to find here. So let's do it carefully. Now, first of all, if you look at this question's condition, we have a cylindrical bucket, and the content, the sand which is poured in the the cylindrical bucket is what is poured down to form a conical heap. So that means what we can understand here, this content is what is getting transferred to another shape. That means the volumes will be the same. So which means it's very clear that volume of the cone will be same as the volume of the cylinder. Is the idea clear? Yes. Because the same content is what is getting transferred. That's the reason. Now, when you come to put the formulas and get the values itself, we can easily solve it. So yeah, let's do it. Left hand side, we have the volume of a cone. Volume of the cone is 1 by 3 pi r square, because we don't know what is the radius of this cone. That's what we need to find here in this first subdivision. So I'm taking the radius of the cone to be r square into h will come into, what about the h? Height of the cone is what? It is going to be 24 centimeter. It's there in the question itself. So into 24 is going to be same as, now right side I have volume of the cylinder. Volume of the cylinder is going to be pi r square h. So pi into, what about the radius of the cylinder? It's going to be 18 centimeter, right? So that means r square means 18 into 18 multiplied by h. H means height of the cylinder. Height of the cylinder is going to be 32 centimeter. Okay, I'm noting it, 32. That's it. Now we formed an equation. When I solve this equation itself, we will be able to get the value of this r. That's it. Okay. So how I can simplify this is, first of all, I can cut pi and pi on both the sides. Next is I will cut this 3 and 24 8 times. And what next I can do is, I can cut this 8 with this 32 for 4 times, right? So that means I got r square is equal to, because left hand side we only have r square, that is equal to, now right hand side you see I have 18 into 18 into 4. Now this can be written as 18 square into this 4, I am writing it as 2 square. Correct? Okay, yes. Now next I can simply have, we have a easy equation, we got an easy equation. Now see here, we can simply, from this we can get it as r square is equal to 18, 18 square into 2 square means r is equal to, simply I can get 18 into 2, which means r is equal to 36, and the units will be centimeter. So the radius of the conical heap formed is 36 centimeter. Okay, we successfully got this. But we also need to find the slant height of this conical portion. So next we will find the slant height. Slant height is nothing but L. L we know how to find it. L is going to be square root of r square plus h square. We already have got the value of r. R is going to be 36 centimeter. And h is there in the question itself. Height of the cone portion is 24 centimeter. Just substitute it here. We will be able to get the answer for L also. So L will be nothing but square root of r square is going to be 36 square plus h square is going to be 24 square. Now please don't complicate. Don't find the value of what is 36 square, 24 square. Nothing needed. We can just do some simple adjustments here. What we can do is square root of, just see here, both these numbers are divisible in 12. So I will take a 12 square as common outside. So inside I will be having what? I will be having here from 36, if I take a 12, I will have a 3 square inside, plus from 24, if I remove a 12, I will have a 2 square inside. I hope you understand this. Okay, yes. Now once again what I will do is I will take this 12 square itself out of the root. When 12 square comes out of the square root, it comes as 12. So simply 12 square root of, now you see here, now I have inside only this 3 square plus 2 square. This is easy for us to calculate. So 3 square is 9. 2 square is 4. So 9 plus 4 will be 13. So 12 root 13 centimeter is going to be the answer. Okay, yes, because we cannot further simplify this. So it will come in decimals. So we will leave it as it is. So yeah, so that means these are the answers. So the radius of the conical portion is going to be 36 centimeter. Slant height of the cone is going to be 12 root 13 centimeters. So these are going to be the answers for your question number 24. Next is question number 25 with us. A hollow sphere of internal and external radii 6 centimeter and 8 centimeter respectively is melted and recast into small cones of base radius 2 centimeter and height is 8 centimeter. Now find the number of cones formed. This is going to be the question. So very similar to the questions that we have worked earlier. So one solid getting transformed into another solid or solids, uniform shape of solids. Okay, so that way we have this question. So the usual way we have to solve this. So here they are melting a hollow sphere. So that means the content is going to remain the same. The volume of the hollow sphere will be same as what? They are going to recast it into what? They are going to recast into small cones. Volume of all the cones. Okay, so let me write it like this: n into, where n stands for the number of cones they are forming there, so n into volume of each cone, so this way if we do, we have we'll be easily able to solve the problem. Now we already know the volume of cones formula, which is going to be 1 by 3 pi r square h. But what about the left hand side volume of a hollow sphere? Volume of a hollow sphere is going to be very similar to the volume of a full sphere, because you see, you have a full complete solid sphere for which the volume is going to be 4 by 3 pi r cube, where r is the radius. But what about a hollow sphere? Hollow sphere means it will be a sphere inside which you are going to remove another sphere. Okay, the inside space is going to be a hollow portion. For example, you take a tennis ball, you break it and see, you will have it to be hollow, right? So that's an example of a hollow sphere, I can tell. So for which the volume will be 4 by 3 pi r cube minus r cube, where this capital R stands for the external radius, small r stands for the internal radius. So the idea here is very simple. From the outer sphere's volume, you remove the inner sphere's volume, you will get the volume of the solid. That's all. Okay, yes, fine. Now coming here, I can very well use these formulas here. Why? Because we have the radii value given here in the question itself. So capital R is going to be what? It's going to be the external and internal radius. Okay, external radius is going to be 8 centimeter, and small r is going to be the radius, internal radii, which is going to be 6 centimeter. Okay, so now we are clear with the values. Come to the left hand side. Volume of the hollow sphere is going to be 4 by 3 pi r cube, that means 8 cube minus small r cube, 6 cube. Okay, yes, now this will be same as, come to the right hand side, n into, now right hand side we have volume of the cone. Volume of the cone we all know very well, 1 by 3 into pi r square h. Now what about the radius and height of the cone? Radius is going to be 2 centimeter. The cone's base radius is going to be 2 centimeters, so 2 into 2 into, and height is going to be 8. Okay, it's fine. That's it. Now we are clear with the things. So now what next we can do is, we have to now solve for the n value. That's it, very simple. Okay, so first of all, I can cut this pi by 3 both the sides. And what next I can cut is, I can also cut this 4 with this 2's are 4. Now I am simply left with here n into 8 is equal to, right hand side I have 8 cube minus 6 cube. That's all. Now when I solve for n, I can easily get the answer. So n will be nothing but, let me do this way. Okay, so 8 cube by 8 minus 6 cube by 8. Okay, I'm individually dividing my right hand side by 8. Okay, because 8 cube 6 cube we need to find the values, that's why. Now this will be very easy for us to find. So 8 cube by, this is 8, that means this will be nothing but 8 square, right? So this will be 64 minus, now what about 6 cube by 8? This 8 is actually 2 cube, so 6 cube by 2 cube will be nothing but 3 cube, which is 27. So this is very cool to see, right? So that means n is equal to 64 minus 27. Now I can easily subtract this. So this is like 14, so 14 minus 7 will be 7. This becomes 5, so 5 minus 2 is 3, so 37. That means 37 cones can be formed. So n is equal to 37 is going to be the answer for your question number 25. But 26, a vessel in the form of an inverted cone, its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. So for this cone only, they are given the height and also the radius. Okay, so let's take a note of it. So for this cone, the radius is going to be what? It's going to be, okay, radius is going to be 5 centimeter and the height is going to be what? Height is going to be 8 centimeter. Okay, you have noted this. Okay, what next is given? It is filled with water up to the brim. Okay, so till the top level brim, the water is going to be filled there. Okay, and that means you will be able to calculate how much amount of water or how much volume of water is filled there in this cone. Okay, yes. Now let's see, continue this question. When lead shots, each of which is a sphere of radius 0.5 centimeter. Now they are just putting some lead shots inside. Now that is going to be spear shape. Now for the sphere, the radius is going to be how much? It's going to be 0.5 centimeter. Okay, so 0.5 centimeter means we'll take it to be half a centimeter. Okay, yes, are dropped into the vessel, then what happens is 1/4 of the water flows out. So because of we are dropping lead shots inside, what happens is whatever water we have there inside the cone, 1/4 portion of the water is flowing out. Then in that case, find the number of lead shots dropped. Okay, yes, this is again very similar to the questions that we have seen previously. Now how we are going to make the comparison here is, here the idea is going to be very simple. Only because of lead shots are dropped in, water is coming out, is it or not? So for that reason, how I am going to equate is the water which is overflown. Okay, so the volume of water overflown. Now this will be same as what? Now this will be same as the volume of all the lead shots that we dropped inside the vessel. That's it. That's a simple idea. Now what about the volume of the total volume of lead shots dropped in? That's going to be nothing but number of lead shots. Okay, let me take that number as usual, n into volume of each lead shot. That means the volume of each sphere. Okay, let's take it like this. Okay, now we very well know what about the volume of water overflown. Volume of water overflown will be nothing but 1/4 of, okay, 1/4 of the volume of the cone. That's it. Volume of the cone formula we all know very well. It is going to be 1/3 into pi into r square h, which means 5 into 5 into 8. Now this is your left hand side. This will be same as right hand side, n into volume of each sphere. Now we also know about the sphere. Radius is half a centimeter and volume of a sphere is going to be 4/3 pi r cube. R cube means 1/2 into 1/2 into 1/2. So this is going to be the radius. So we have to cube it, right? So 3 times. So now when we clearly solve this equation itself, we'll be able to get the value of this n. That's it. So let's carefully solve this. Too many values we have. So first of all, I can as usual cut this pi by 3 both the sides. And what next I can cut is, I can also cut I can also cut it like this 4 and this 8 for 2 times. So I have my left hand side having with I have the value like how much I have, 5 into 5 into 2. So 5 into 5 into 2, and my right hand side I can even cut this 2 2s are 4. This way I can cut it. So I will be having simply n/2 on my left hand side. Okay, so which means n is equal to 5 into 5 into 2 into, take this 2 also here, so 2 into 2. So now when I multiply this, I will be getting 25 4s are 100. So that means how many lead shots are dropped in? 100 lead shots are dropped into the vessel, the conical vessel. So 100 is going to be the answer for your question number 26. Here with the last question, question number 27. So here we have a container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter, is full of ice cream. So there is a cylinder shaped container. They gave the diameter is 12 centimeter. From this itself we can understand that the radius of the cylinder is going to be 6 centimeter. Okay, I am noting it here itself. And height is 15 centimeter, and this container is going to be full of ice cream. Now the ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter, having a hemispherical shape on the top. So now they are going to fill ice creams, cone ice creams, and this is how the shape of the cone ice cream will look like. Now you can see a cone here. The cone will be filled, and at the top of the cone is they are going to keep a hemisphere. Okay, yes. So now this way they are going to fill the ice creams. And remember, they also gave the dimensions of this cone. Now what about this cone? For this cone they gave the height is 12 centimeter. Okay, so height is 12 centimeter and also diameter is 6 centimeter. So when diameter of this cone is going to be 6 centimeter, means radius is going to be half of that, which means 3 centimeter. Okay, yes, yeah, the idea is now clear. Now if at all they want to do like this, how many cones they can fill? Now remember, the hemisphere at the top which you see is also going to have the same radius, 3 centimeter. Okay, common radius that we have to remember. Now as usual, we are going to deal the problem in the same way. We need to find the number of such cones formed. So to find the number, as usual method, so start from that cylinder, the original shape cylinder. Now the volume of the cylinder is what is going to be equal to the volume of amount of ice cream that is filled in all these cones. Okay, yes, and along with the hemisphere at the top. Okay, so that means Left hand side I will have volume of the cylinder. This will be same as, let's take the number of ice creams which we are forming to be n. So n times of what we will have inside. Now each of the ice cream contains the cone content. So that means volume of the cone along with the volume of the hemisphere also, because at the top we are placing a hemisphere. So volume of hemisphere also. Okay. So hemisphere, I'm writing in short. So this is what we have to use. Now we know the formulas for all these things. Let's use the formula along with the values and solve this problem. Now come to the left hand side. Volume of the cylinder is going to be pi into r square h. Okay, now what about the radius of the cylinder? That's going to be 6 into 6 into because r square, right? So 6 into 6 into, what about the height? Height is going to be 15. Okay, now this will be same as, right hand side I have n into what about the volume of a cone? Volume of the cone is going to be 1 by 3 pi into r square h. So 1 by 3 pi r square h is the formula, right? So for cone the radius is 3. So 3 into for the cone the height is going to be 12. So 12, right? Okay, plus now come here, volume of the hemisphere. What about the volume of the hemisphere? That's going to be 2 by 3 into pi r cube. R cube means we will have 3 into 3 into 3. Okay, yes. So yeah, this is what we have here. Now when you try to simplify this carefully itself, we can easily get the answer. So I will have now have pi into 6 into 6 into 15 is equal to, now let's carefully work this problem, n multiplied by, let's try to simplify itself. So 3 and 3 I can cut here, also 3 and 3 I can cut it. So I will be having how much here? I will be having better I will take a pi as common. Okay, so n into pi, I will take pi and pi common from both these expressions. So inside I will be having pi into, here I am left with 3 into 12, which is 36, plus here we have 2 into 3 into 3. So 2 into 3 into 3 will be 18, correct? Yeah, 18. So this is what we will be having on my right hand side. So let me clearly check it, whatever the things we have done. Yeah, 3 everything is cut. So here we have only 36 and here we have 3 into 3 into 2, which will be 18. Okay, yes. Now what next is, I can even cut this pi and pi on both the sides. So my left hand side I will be having 6 into 6 into 15 is same as n into, now what about this 36 plus 18? This will be 54 actually, is it or not? Yes, 54. Now what next I can now do is, I can cut this 6 with this 54. This will be for 9 times, yes. And what next I can also do is, I can even cut this 9 with in 3 tables 3 times. This 9 in 6 in 3 tables is 2 times. And once again I can cut this 3 and 15 for 5 times. So I will have n is equal to just 2 into 5, which will be 10. So n is equal to 10 is going to be the answer. So we can form 10 such ice creams when we just try to pour the content. Okay, when we try to transfer the content from the cylinder to these cones along with the hemisphere, we can form 10 ice creams. Okay, so how many such cones are formed? 10 such cones are formed. So 10 is going to be the answer for your question number 27. So successfully we have completed all the problems from this particular exercise. I believe like all these problems, the solutions, the way we solved, everything is clear to you. And yes, of course, any doubts you can post it in the comment box. And if you are expecting any other exercise, you can also comment it. I'll see to prepare for that exercise also and post the solution video. Again, let's catch up in some other video session. See you there. Thank you so much.